Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station. And we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
One prime objective of NASA's manned Gemini flights will be that of two craft meeting and joining in space. The perfection of this critical maneuver will be important for later Apollo moon missions. And here's one means of preparing for that space maneuver before actual flight. It's with a docking simulator, a device that
Hi, my name is Dr. Emily Schaller, and I'm here at NASA's Wallops Flight Facility on the eastern shore of Virginia. We're here because NASA is using airplanes to study hurricanes. The mission is called HS-3, which stands for the Hurricane and Severe Storm Sentinel. What's a Severe Storm Sentinel? It's actually a remotely controlled airplane called the Global Hawk Unmanned Aerial Vehicle, or UAV. Pilots fly the plane from a cockpit on the ground. NASA is using these Global Hawks to study hurricanes in the Atlantic Ocean by flying over and around them. The Global Hawk can fly for very long periods of time at very high altitudes. It can fly almost twice as high as a commercial jet, and it can fly for over 24 hours without stopping. That's why scientists are using the Global Hawk for the HS-3 mission, so they can continuously study storms as they develop. Forecasters have a pretty good idea of where these storms go, but what they want to know is, will they grow? We spoke with NASA mission scientists about how the Global Hawk will help improve their understanding of hurricane formation and growth, and why it's so important for us to learn more about hurricanes.
The Hurricane and Severe Storm Sentinel has a goal to try to better understand the processes that control the intensity of storms. The ability to predict the intensity is very important because it impacts people in the coastal zones who, if they're anticipating, say, a tropical storm, a Category 1 storm, and they end up getting a Category 3 storm, it makes a big difference in terms of their ability to prepare and deal with the storm consequences.
And this is really important because a category of a hurricane is the intensity of the winds associated with a hurricane. So a Category 5 hurricane is much more destructive than a Category 1. So being able to predict the difference between just a tropical storm, a Category 1, up to a Category 5 is really crucial to saving lives and lessening damage and so forth, particularly saving lives.
The benefit of HS-3 compared to any other hurricane mission is the fact that we have these planes able to fly upwards of 24 hours, and being able to monitor a storm for that long period of time and getting constant data, we can actually catch changes in the storm.
We will use two Global Hawks. One Global Hawk flies over vast areas around a hurricane. It measures the environment that a hurricane is embedded in. And then the second Global Hawk, instead of sampling the vast area, it goes right in to look at the eye and the eye wall and the inner core processes of a hurricane.
The Global Hawk unmanned aerial vehicles flown by NASA were originally built for the military and to study the Earth. NASA flew its first science mission with the Global Hawk in 2010.
The Global Hawks are really a new aircraft for doing hurricane studies. Manned aircraft typically fly for, say, 8 to 10 hours when they do a research flight. Of that 8 to 10 hours, you may have 4 hours or more just getting to and from the storm, so that in a typical flight, you only get 4 to 6 hours actually sampling within the storm. With the Global Hawk, we can get 3 times, sometimes even 4 times as much as you can get with manned aircraft.
Now this plane can fly to 65,000 feet. It can fly 13 miles up. It can also fly for nearly 30 hours. So this plane can take off here from Virginia, on the coastline of Virginia, close to where hurricanes form. It can fly all the way to Africa. It can spend about 10 hours on the coastline of Africa and then fly all the way back. There's no plane that can do that in the NASA vehicles that we have.
Because the Global Hawk can fly so high for so long, scientists can study larger areas of the Earth for longer periods of time, in places where planes with pilots on board may not be able to reach. We spoke with pilot Phil Hall about the Global Hawk and what it's like to fly the plane without actually being inside it.
So the two Global Hawks that we're flying for HS3, Air Vehicle 6 and Air Vehicle 1, from a pilot perspective, it's a very different aircraft. We don't have any rudder pedals or a control yoke. We actually use a mouse and keyboard. We actually have a control room on the ground. We have 2 of them now. We have one at Edwards Air Force Base in California, and we have one here at Wallops Flight Facility in Virginia. So it's basically like a trailer. It's been specially designed for Global Hawk. It's full of computer systems that can talk to the aircraft. So we can connect to the internet, and all these satellite products of lightning, the storm from satellite images, we're able to download that almost real time and use that to actually navigate the storm. For the first part of the mission, we actually fly the aircraft from Wallops. And once we get about 2 or 3 hours into our flight, we actually transfer control of the airplane back to Edwards Air Force Base, NASA Dryden Flight Research Center. It's very different from any other kind of aviation operation in that we have pilots on both coasts, and we can actually transfer control of the aircraft during the flight to the other pilots. And when you have these long missions, like 26 or 27 hours, one person can't sit there for the entire flight. So we actually have 3 or 4 shifts of people that come and go to man this aircraft.
Now, pilots know how to fly planes and they can tell the plane where to go, but how does a pilot actually know where to go? You have to have scientific information. Now, scientists sit in a separate trailer. We have computers sitting in front of us. We bring in satellite information. We bring in forecast information. And because weather can change so fast, they can collect that information, interpret it, and then relay it to the pilots and say, well, instead of going over to this point, why don't you go over to this point over here, which is where we think the eye has relocated. So it's a great team between the scientists and the pilots to actually get the most information you can out of a flight.
How can you become involved in our mission? You can follow the plane too, just like the pilots and scientists do, by participating in live chats where you can get live updates on where the plane is flying right from your own classroom.
You can definitely be a part of our mission by actually being able to look at the same screen we're looking at. I'm looking at where the plane is flying with respect to the storm, and you have access to the same data I get to look at. You have access to see the plane's altitude, you can see the wind speeds, you can see the wind direction, and you can chat live with pilots, with forecasters, mission scientists, and we're looking at the same thing you are, and that's just really exciting to know that you can ask us any question at any time, and we are right there looking at the same thing.
To learn more about our mission, visit nasa.gov/HS3. See you next time on NASA Airborne.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan asteroids. These primitive bodies share Jupiter's orbit in two vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids, embarking on a 12-year odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
Station, this is Houston. Are you ready for the event?
Hello, Houston. The Expedition 63 crew is ready for the event.
JSCPAO, this is Mission Control Houston. Please call station for a voice check.
Station, this is JSCPAO. How do you hear me?
JSCPAO, loud and clear.
Great. We'll start this off with a question from Twitter. It's probably for you, Chris. It's from Rick. When they opened the hatch, did Dragon have that new car smell?
It absolutely did. In fact, there was a little bit of space smell in the vestibule, and then when we got that hatch open, you could tell it was a brand new vehicle with smiley faces on the other side, smiley face on mine, just as if you had bought a new car, the same kind of reaction. Wonderful to see, my friends, and wonderful to see a brand new vehicle.
All right, we'll start off with a question from Bill Harwood, CBS. Let's start off with a question from Bill Harwood, CBS.
Hey, can you hear me now? Testing 1, 2. Could you guys hear me now?
Loud and clear, Bill.
Okay, sorry about that. I just want to go back to what Bob was saying yesterday, describing the ride uphill. You were comparing it a little bit to shuttle. I was more interested in how did the first stage of the Falcon 9 feel compared to the shuttle when it was on solids? How did the second stage feel? You made it sound like maybe it was a little rougher than the shuttle on the main engines. And just wondering if there was ever a point in there when you looked over at Doug and went, wow, this isn't quite what I was expecting.
Well, Bill, you took the words right out of our mouth. The summary from yesterday was good, smoother first stage, a little rougher second stage than we saw on shuttle, and that I think both of us were expecting. We did actually comment on it while we were going uphill. I think we tried to verbalize as much of the new experiences we were having just to make sure they were for real between the two of us. We were sensing the same things.
All right, let's go to a question from Stephen Clark.
Hi, thanks for taking my question. Stephen Clark from Spaceflight Now. Just to follow up on that, what was the sensation at MECO and its stage separation, since that's something that was not experienced really during shuttle, to shut down the engines and then ignite a new engine in flight? I'm also curious about how your experiences were with the spacesuits in flight. Thank you very much.
I think the question was about the difference with staging between the space shuttle and the Dragon, since we didn't shut down the main engines on the space shuttle like we went through for first stage and second stage. There was a significant difference between the solid rocket boosters on the shuttle and that second stage, and so I think we all definitely felt that separation and heard the clunk associated with it. Doug and I both commented on, I think Doug commented on it first, that we did feel some early zero-G when we came off of the first stage, and we're getting ready to transition to the second stage, and then we felt that second stage light. And I think the next question was about the suits. And let Doug, if you want to talk a little bit about our experience with the suits.
Yeah, the suits in general, Bob and I have had a ton of time in those suits. I bet you we've donned and doffed those suits a couple hundred times. So the suits themselves, if you're not familiar with them, they're custom designed and custom fitted, so they're very comfortable. They were actually much easier to get in and out of in zero-G, as we figured out over the course of the 2 days. And we complimented the suit team. Those things worked very well, and everything we expected going uphill.
Lauren Gresh, The Verge.
Is there any perhaps feedback for SpaceX and NASA that you have about any potential changes that you would make for the next crews who fly on Crew Dragon?
Were there any changes that we would make? I think it was your question. I don't think that there's anything.
We're not hearing you, Lauren. Let's move on to Rosa on Aragon.
Hi, for taking my question, and I'm glad to see you all are well up there. As you know, Houston is the home to manned space flight, and in many ways, the people here who know you personally from Timber Grove, Clear Lake, those who've watched from Nassau Bay, Webster, seen you train and your journey to get where you're at today. Some of them may be like your sons who are younger and may be inspired by the things that you all are doing. What is your message to those who are watching from Houston, from all of these areas in Space City? What's your message to them?
Well, I think my first thing I would say about that is, just never quit what you're doing. This was an extremely long road for Bob and I. We last flew in 2010 and 2011, and then when NASA stopped flying shuttles, that was in the middle of 2011, and it's just taken that hard work and dedication over the last almost 9 years to get us where we're at now, back in launching rockets from the United States, back at Space Station, docking to the front of Space Station where shuttle used to dock. And I would just say, take a message from NASA in that anything is possible. We've had a really rough couple of months, and just to be able to show the country what the agency's made of, what the Commercial Crew program did, and what SpaceX did, I hope they take some pride and a sense of accomplishment of seeing that.
I think for both of us also, the Houston area is where we call home now. And it certainly is true that the home of Johnson Space Center, the home of human space flight, takes seriously that that's our home. That is the home of human space flight. We have excellent support there. I had a parade of appropriately, interestingly, social distancing individuals lining my neighborhood in the half mile or so as I departed on my way to the Ellington Field to head down to Florida. And I know that I just had wonderful support. And I'm to all our friends and families at home, thank you guys for everything. And we just couldn't have done it without all of you.
Thank you so much. I know that probably means so much to them. Godspeed.
Let's go to a question from Chris Davenport.
Hey guys, it's Chris Davenport from the Washington Post. Thanks for taking the time, and congrats on your flight. And I'll try not to leave you hanging this time. To follow up on Bill and Stephen's question about the ride, I wonder if you can walk us through, some of the technological differences between shuttle that led to the difference in the experiences, and then maybe a little bit more of what were some of the key moments during the ascent phase that stood out to you guys. Thank you.
Hey, Chris, good to talk with you. I think just generically, the Falcon 9 is a liquid-fueled rocket. Remember, shuttle had solid rocket boosters to start with. Those burned very rough for the first 2.5 minutes. The first stage with Falcon 9 were the 9 Merlin engines, and roughly the same amount of time, and it was a much smoother ride, obviously, because it was a liquid engine ascent at that point. Where the differences started for, I think, both Bob and I, and we commented on it at the moment, was at staging. And it was very similar to what you saw in the Apollo 13 movie, where they staged from first to second stage. So the first stage engine shut off, and then it takes a second, almost a second, might have been less than that, but it seemed like it took some time between the booster separating and then the Merlin vacuum engine starting. And so at that point, we go from roughly 3 Gs to 0 Gs for, I don't know, half a second probably. And then when that Merlin vacuum engine fires, then we start accelerating again for the next 5-6 minutes until we achieve orbit. So totally different than shuttle. It was smooth. It got a little rougher, as Bob had mentioned before, with the Merlin vacuum engine, and it'll be interesting to talk to the SpaceX folks to find out why it was a little bit rougher ride on second stage than it was for shuttle on those 3 main engines.
All right, let's try Marcia Dunn from the Associated Press.
Hey, Doug, good to see everybody up there. I'm wondering, have you captured the flag yet? Have you actually put your hands on it? Is it aboard Dragon? And what are your thoughts about laying claim to that flag, since you are one of the ones who put it there 9 long years ago? Thanks a lot.
Hey, Marcia. The short answer is Chris had it right on the hatch where we left it 9 years ago. And it's right here. And I think he's got a note, do not forget to take with Crew Dragon. So depending on how long we stay up here, you can bet we will take it with us when we depart back to Earth. From that standpoint, I think, we have talked about this flag before many times over the last 9 years since we left it here on STS-135. And I think the important point is, as I said before, just returning launch capability to the United States to and from the International Space Station. And that's what this flag really means. And I think a little bit more, it's to the thousands of people that made it possible, from the folks at SpaceX to the folks at NASA to the folks within the Commercial Crew program. And we just are lucky enough to be able to take it home with us, and that'll be our plan here in a month or 2 or 3 or 4, depending on what, as Bob says, what Uncle Kirk lets us do.
Let's go to a question from Mark Carreau, Aviation Week.
Mark Carreau, Aviation Week. My question's for Chris Cassidy. From your perspective, what skills and ISS training do Doug and Bob bring to the ISS mix, especially now, and how will those help to ramp up operations internally and perhaps externally in the coming weeks?
Well, experience goes a long way, and both these guys, this is their 3rd flight, and so it really doesn't matter, in my opinion, shuttle flight experience or station flight experience. It's all has to do with working in space, working efficiently, understanding the system and the methodology with which we work back and forth and hand in hand with mission control. And once you understand that and grasp all those concepts, the work part is, I don't want to say easy, but it just kind of happens together. And we've already seen that. Today is day 1, and they're hitting the ground running, unloading the vehicle, and we've got HTV right at our feet, and we'll be working in there in very short order, probably after we hang up from this conversation. Together, the 3 of us will be tackling the overall mission of the space station, which is conducting science, enabling that science with maintaining the space station, and then there's some operational objectives sprinkled in the mix. At some point, we'll get a plan for potential spacewalks, and we'll execute all that. We don't just sit up here at dinner and decide when all those activities are going to be done. The prioritization is done in Houston, and then we execute the plan. So the 3 of us are pretty excited to get after it together.
Joy Roulette with Reuters.
Hey, thanks for doing this. I was wondering, so since you guys made it to the space station, how does it feel, I guess, not knowing how long you guys are going to stay there for? Does it feel weird? And I was also wondering if any time during the trip to the space station, that if you guys noticed anything unexpected that you didn't experience during training or sims. Thanks.
Well, thank you. It's a good question. I think several recent crews have had a little bit more uncertainty than we've had historically for how long their mission duration was going to be. But I guess maybe on the percentage scale, Doug and I have maybe the most uncertainty, because it could be relatively short, or we could potentially double or triple maybe what was originally expected for us just a few short months ago. And so it's a little bit strange. I'm trying to explain it to my son, just 6 years old, and from his perspective, he's just excited that we're going to get a dog when I get home, and so he's accepting that uncertainty and continuing to send messages to me while I'm on orbit. As far as unexpected things while we were headed uphill, I think I said a little bit about this yesterday, but the biggest differences are just the dynamics that's involved, the vibration, the experiences that we felt actually riding a real rocket, going through the fueling operation. That was a new experience for us. As you probably know, the space shuttle was fueled when the astronauts arrived. Doug and I went through the fueling operation on board Dragon, which was different from us. And so going through the hearing the venting and the valve sounds and the little vibrations associated with that operation was a new experience for us, and so that was a little bit different than training, but nothing out of family. The team did a really great job of recording that audio during the Demo 1 mission, during the mission that was a little bit over a year ago that came to space station with no people on board, and played that back for us tied to the audio. So we've heard all those sounds pretty much before, and so that was extremely helpful. We have the same tool for coming home, and look forward to seeing how well that matches up with our experience.
Robert Perlman.
Thank you. Hi, Chris, Doug, and Bob. For Doug and Bob, I wonder, during the ascent or during your overnight period, was there a point where the sense of history sort of seeped in, where you allowed yourself to just consider the history that you were making? What were those specific moments? Thanks.
Honestly, Robert, good to talk to you. I don't know if we ever reflected on it over the 19-hour rendezvous. I mean, I think you may have random thoughts going through your head every now and again, but both Bob and I are over the last 5 years been pretty focused on this mission and actually flying this mission, and I think that's really what we put our entire effort mentally and physically into. From the time we walked out of the ONC building until we docked with Space Station, and of course we're still doing it, but was just focusing on everything we could do to make sure we did what we needed to do to make it a successful ascent and rendezvous and docking, and then also try to take in all the things that the Falcon 9 and the Dragon showed us, the noises, the maneuvers, any nuances, anything that we can let other folks know to be aware of as they fly that vehicle. And I think, for me anyway, the historical aspect of it is certainly notable, but I think it's something to maybe consider after this mission's complete. We're not even in any way, shape, or form halfway through the mission yet. We've just docked. We still got to do our mission here with Chris, and then undock, depart, and do a re-entry, and then a landing, and then a recovery. So plenty of work to do, and we'll probably think a lot more about that when the time comes.
Hanukkah Whitering with Space.com.
Hey guys, Hanukkah Whitering here. Thanks for taking my question. This is for Bob and Doug. I'm wondering, what were some of the first things that you wanted to see or do after you arrived at the space station? And has it changed much since you were last there, or does it still kind of feel like a second home to you? Thanks.
Well, I don't want to speak for Doug on this one, but one of the things I was most excited about was being able to make a phone call home. It's been a long time since I launched into orbit, and I've got a little boy who got a chance to watch me do that for the first time in his life, and I just wanted to understand what his experience was and share that a little bit with him while it was still fresh in his mind. He was able to make the trip back to Houston after watching the docking from down in Florida, and was pretty excited about the whole thing. So that was wonderful for me. As far as the space station goes, I'll tell you, it seems a lot like it did when I was here last. There is quite a bit more science going on, quite a bit more equipment on some of the rack faces, especially over on the gym side or down in Node 3. But the overall structure and layout is very similar. We did comment yesterday about the airlock configuration. It's not as clean as how Chris and I remember it from our shuttle experiences, because those flights were really about the assembly of Space Station, and the airlock was ready to go. And we're in a different mode of operation on board Space Station right now. So I know the way Space Station works is you pretty much have to configure each specific area for the task at hand. And so the mating adapter that we docked to on the forward part of the space station was all cleared out for our arrival. All that stowage was moved around. Quite a bit of stowage was probably repositioned for HTV's arrival from Japan, and we'll have to do some reconfiguration in other areas as we continue to conduct operations on board the space station. There's just so much going on that you've got more stuff than you have places to just stow it without fully being able to conduct the operation. Anything to add, Doug?
Let's go across the pond to Jackie Goddard with the Times.
Thank you. I'm Jackie Goddard for the Times of London, and congratulations. This mission feels so much more funky and futuristic, with everything from the capsule's look to the touch screens, the technology, the suits. Does this feel like the Jetsons? Can you describe some of the emotion around it, of the ride uphill? And somebody has to ask it that all-important question that the child in all of us needs to know: how was the Crew Dragon toilet? Thank you.
Well, it's good to talk to you. Let me think. From a futuristic standpoint, I think, SpaceX, from the very start of that company, has tried to be very forward-thinking and cutting edge, and it is one of the factors that went into the design of the Crew Dragon and our spacesuits and everything about the vehicle. And, for us as the test pilots, so to speak, we're there to evaluate how it does the mission, and so far it's done just absolutely spectacularly. It's a very clean vehicle. I think most people think it's a really cool-looking vehicle. I know my son thinks so, and it does everything we need it to do for this mission. So we're very happy with that part of it. Let's see, the toilet. I think we had a bet to see when that question was going to be asked about Dragon, and it works very similar to the one we were used to in the space shuttle, and it worked very well. We had no issues with it.
All right, next is Peter King.
Good morning, Peter King with CBS News Radio, and I know, Bob and Doug, that you were up there to help Chris overcome that shorthanded situation, but it also gives the SpaceX people a chance to evaluate the Dragon's long-term performance during its exposure to the elements while you're up there. What are some of the things they're going to be looking for?
Well, you're absolutely right that we'll put the Dragon through its paces in preparation for the Crew 1 flight. We already spent quite a bit of the day preparing basically Dragon to serve its purpose as a lifeboat or an emergency departure vehicle. So Doug and I spent quite a bit of time getting the equipment prepared so that vehicle is ready to go and execute that mission. And we probably did a little more as a part of that than other crews will do in the future. We've performed some connections with the computer systems to make sure that we can configure the communication between everything from the Soyuz to the rest of the space station back to Dragon if we needed to do that from inside of our small little vehicle, and we established that stuff all works. And we'll continue to do small checkouts like that. We'll go through the process of powering down Dragon, taking it to its kind of hibernated state, and then bring it back up here in just a few short days just to make sure that process goes smoothly. Again, every crew won't need to do that sort of an evaluation, but since it's the first flight, we really are putting her through her paces to make sure that any of the little aspects of the mission that it might be called upon to support, it's ready to do that. And so that's from the hibernated state, that's from a regular departure, or to, serve as another environment for us to go and safe haven in should we need to if there was a problem on board space station. And we'll do all those things before we call her operational, and then really pick up with a primary task focused on helping Chris out on the space station side.
Leo Enright with Irish Television.
Congratulations, Bob and Doug, and as we say in Ireland, slán a bhaile, safe home. I have another question about launch and about something that was different this time. Your final call-out before SECO was Shannon, to which Hawthorne replied, Roger, Shannon. Now, obviously, Shannon is in Ireland, and I rather expect that we're going to be hearing this call-out a lot in the years to come. So a lot of people in Ireland are wondering, what was that all about?
Well, hello, Ireland. That's a great question. So the ascent trajectory offers us some opportunities if needed, if we have got a failure with the launch vehicle, to abort. And some of those scenarios involve aborting fairly close to Kennedy Space Center, along the east coast of the United States, all the way up towards Newfoundland, even into Canada. And then once our trajectory hits a certain point and we get high enough, we are going to abort forward to the UK and the Ireland area specifically, and we can do that in the later stages of our powered flight before the engine shut down. So that's our call to Mission Control in Hawthorne, to let them know that we see that change in the abort destination if that eventuality is needed.
Sophie Sanchez, Chicago Now.
Hola from Chicago. Doug, as a test pilot, what was it like for you taking control of Endeavour for the first time? And then if you can both share a little bit about the docking procedure, how it compared to the Soyuz docking procedure. Thank you.
Flying the Dragon was exactly how we expected it to be, and that was one of the reasons we wanted to do the manual flight test twice. So we did it shortly after we got to orbit on our first day, and then when we were on the final portion of the docking axis, we did it again yesterday. And it's all to prove that that capability works for future crews if need be. Most folks are familiar with the fact that Dragon is designed to be totally automated from the time it launches until the time it returns to Earth. But if there's any systems failures or other issues, we would like to know with confidence that if we take over manually, the vehicle will do what we need it to do.
Dave Mosier.
Oh. Thank you so much for taking my call, and congratulations on your flight. It was amazing to watch. Chris, what was the biggest thing you felt or thought as Endeavour approached the ISS? And Bob and Doug, same question for you. What were your biggest thoughts or emotions as you pulled up to this place you haven't been in many years? And I'm also curious. I want to ask the spacesuit question a different way. What's your 5-star review? Well, what would you rate it? What would you say about the spacesuits and if you had to review them online? Thank you.
I'll take the first part of that question from the space station side of things. What was going through my mind while they were, there's sort of several phases. One was during launch, and that was quite exciting for the three of us on board. We flew directly over the Kennedy Space Center 2 minutes before launch, got some nice pictures of the launch pad. We were out over the ocean at the time of engine ignition, so we couldn't quite see. Plus, we were in the day, and KSC was in the day, so we didn't see the actual launch. But that was very, very exciting, and the three of us were just cheering, just much like you were, I'm sure. Fast forward to yesterday when we were watching the vehicle do its stair-step maneuver up to our altitude, and Yvonne and I could see, we were looking out the cupola window, we saw it very far away, about 19, 20 kilometers, and then it got brighter and brighter and bigger, and it struck me that little tiny dot was going to be fixed to a piece of metal that was about 15 meters from where I was standing, so to speak. And then they came up to our same altitude and started coming directly in on the docking axis. And I had the camera out at one particular point, and I cracked open the window to get a picture, and I realized that inside that spacecraft were two of my colleagues and friends, and they're going 17,500 miles an hour, and we're going 17,500 miles an hour, and we are bringing these two vehicles together with a computer and them backing it up, and I could monitor this process on the telemetry. And so from a technical nature, I was pretty amazed at the whole thing, just realizing what was happening. But then you fold into that the historic aspect of the whole day and what it means to America, what it means to our nation's space program, what it means to international cooperation and commercial cooperation. It just was kind of awe-inspiring, to be honest with you. And then that was a fleeting moment back to the operations, but it was pretty impressive day, and I'm just honored to be a part of it.
As far as the docking was concerned, Dragon flew pretty similar to Shuttle. It had very similar characteristics. The automation would have did make the same corrections that I think either Bob or I would have as we were coming in. And the thing that really stood out to both of us, and we mentioned it as soon as we docked, is we didn't feel the docking. It was just so smooth, and then we were docked, which in Shuttle you felt a little bit of a jolt, nothing real heavy, but you felt it. And we asked the guys on board station the same question, and they said we didn't feel it either, which is typical, more typical. But anyway, that really, really surprised me. So that either just the velocities or the strength of the docking mechanism really absorbed any inertia as we came into dock, and it was pretty neat that we couldn't feel anything at all on board Endeavour.
I think for both Doug and I, we'd have to give the suits a 5-star rating. You know, each suit is point designed for a very specific mission. This one is point designed for us to sit in our seats and protect us if there's a fire or any sort of a problem with the atmosphere on board Dragon. It's leaking out or has smoke in it or anything like that. And so these suits didn't have to do that job for us, which was nice. But it was clear that they were ready. We had great checks of the suits as we continued uphill and pre-launch, and I just can't say enough about the SpaceX team, Chris Trigg, Eric, Maria, and all the other members of that team have just done an outstanding job supporting us, getting them tailor fit to fit on us, and we look forward to seeing how they perform.
Station, this is Houston ACR. That concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station.
And that concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station. Thank you to all participants from JSC, PAO, and the media. Station, we are now resuming operational audio communications.
Cape Cod, Massachusetts, is known for its beautiful beaches. This scenic landscape is also home to one of the most frequent marine mammal stranding sites in the world. Scientists know very little about what causes these animals to strand. What has been proven is that a quick and efficient response in these moments is a matter of life and death.
If we can get there quickly and provide supportive care, they have a much better prognosis in terms of survival.
Katie Moore works on the front lines as the Deputy Vice President of Conservation and Animal Welfare at the International Fund for Animal Welfare. Through Katie's fine-tuned rescue efforts, she has increased the survival rate from 14 to 75%. But the question remains, could it be possible to predict rather than react to these events?
If we can develop an algorithm that pieces together the different variables that may be causing mass strandings or driving mass strandings, then we have the ability to then prevent them. We can have teams that are out on the shore looking for animals in those hotspots, knowing that all those variables have come together and this is the likely point in time where we're likely to see it. But we can also have teams ready to respond so that if they do strand, we're there that much faster and more animals will survive the event.
In Cape Cod, the annual number of stranded animals ranges from less than 10 to over 200. Some of the most affected species include pilot whales and white-sided dolphins, creatures that are typically found in deeper water, rather than along the coast. The ongoing search for answers began 400 miles away at the Bureau of Ocean Energy Management in Sterling, Virginia. There, fellow marine biologist Desiree Reeb had some initial thoughts on triggers for these events.
For the large proportion of these strandings, the animals are across the ages, in pretty good health, and there's no really immediate evidence as to why they actually strand.
Geomagnetic perception, or the ability to navigate using Earth's magnetic field, is a feature thought to exist in marine mammals. Could changes in the magnetic field confuse the animals? All the way down to the sea floor, sensors like magnetometers can detect changes in Earth's magnetic field, called geomagnetic pulses or storms. One cause of such changes is activity from the sun, known as space weather.
Geomagnetic perception is one of the theories, and I thought, well, if a magnetometer can pick it up, maybe the animals actually can pick it up.
Dr. Reeb brought her hypothesis to Antti Pulkkinen, research astrophysicist from the Heliophysics Department at NASA's Goddard Space Flight Center in Greenbelt, Maryland.
The coolest thing was that we realized that nobody had really taken a cold, hard data science analysis look at the problems.
By combining Katie's records on marine mammal strandings in Cape Cod and Antti's records of the changes in Earth's magnetic field, the team of researchers had a starting point.
What we were trying to look at here was if there was a potential driver or relationship or correlation between the occurrence of mass strandings and any solar activity.
The data that we have correlated or analyzed so far is information about the local geomagnetic conditions. We have long data records from geophysical observatories of the local geomagnetic field variations and marine mammal strandings.
When the team analyzed all the data, they found that measurements from the same time period, or random time periods, produced similar results, meaning that there is no obvious relationship between geomagnetic changes and strandings in Cape Cod. If space weather wasn't the trigger, what could be?
The easy fix correlation between a geomagnetic pulse and, a stranding doesn't seem to be very evident, but what it does show is that there are multiple variables involved in this equation, and that the geomagnetic storms could just be one very small part of it. Significant still, but it looks like there are multiple oceanographic and environmental elements.
The scientists considered what other variables may exist in the air or water that could change animal behavior. Tides or winds could be disruptive. Ocean color, measurements of the water's chemical and particle content, could reflect changes in the food chain. Perhaps sea surface temperature was a factor too. With the help of data from NASA Earth Science missions, they could also explore these possibilities.
Me personally, it's really driving also an additional motivation in doing something like this.
With more data on hand, it was time to expand the team. They recruited statisticians and the expertise of NASA Earth Science data analyst and oceanographer Erdem Karakulu.
A data set, no matter its shape or content, always has a story to tell. Trying to figure out how different data are connected, I think, require a wide diversity of skills and background knowledge.
For example, I'll be explaining how a mass stranding occurs and how we respond to try and understand why I'm presenting the data in a certain way. And my colleagues from NASA will look at me and ask questions that I wouldn't think to ask because I take for granted my understanding, and they're coming at it from a totally new angle with no background.
The group hopes to combine these data sets in a way that reveals a pattern, allowing them to predict the likelihood and location of mass strandings before they happen.
We've really just sort of slowly peeled the first layer of this onion back. And I think that there's so many more layers that still need to be addressed and looked at. And I hope that we can actually find additional collaborators, additional funding partners to really bring all the data that's really available to really give this the study and the scrutiny that it deserves.
And we are also going to make all these data sets available to the entire scientific community so that we can utilize the entire scientific community to take an attack and approach this problem.
The project's legacy rests not only in a predictive tool, but also as an example for collaborative research moving forward.
I think that there will be other things to take and run with, get new ideas, maybe add more data. And I'm hoping also that it will be a model for how projects can then be open to the wider public.
Just follow you guys that way.
With the potential for an even broader collaboration ahead, Katie's rescue team is optimistic that they will gain a deeper understanding of strandings and ultimately save more lives.
The ability to release animals after they've stranded is tremendous. When we do that, I mean, that's the best feeling in the world after all of that hard work.
Those questions that seem unanswerable, if you give them time and support and effort and put people on them, we can do amazing things.
It is great to be back at America's Space Coast, at this historic place with the men and women of the John F. Kennedy Space Center. And it's here today in the 21st century that the modern marvels that launched from these grounds prove that the public and private sectors are achieving far more together than we ever have apart. American businesses are developing new rockets, spaceships, satellites that are taking us further into space than ever before, and renewing our confidence that we can and will achieve the impossible once again. This truth echoes through the history of the Kennedy Space Center, named for a president who challenged the American people to marshal the best of our, in his words, energies and skills to become the world's leading spacefaring nation. I know America will once again astonish the world with the heights we reach and the wonders we achieve. And as these feats of American enterprise and ingenuity attest, much more than the bridge to space, Kennedy Space Center is the bridge to the future.
report range status. Range green.
T-minus 5, 4, 3, 2, 1. Go for main engine start. 0 and lift off.
This is no ordinary aircraft, and on board is no ordinary spacecraft. This C-5 Super Galaxy is hauling something special.
It can carry what no other airplane can carry in the Air Force. Width, length, weight, you name it, it can get on that thing. This jet can do it like no other jet.
After 2 years of construction at Lockheed Martin in Denver and a few hours in the air, NOAA's GOES-S has finally made it to Kennedy Space Center, where the countdown to T0 begins.
It's always exciting to bring a satellite down to Kennedy Space Center and participate in that whole activity of getting a satellite ready for launch.
Getting it out here and rolling it into the launch processing facility, that was a very big deal for us. It's one of the hugest milestones in any spacecraft program is shipped. It's not easy to transport something like this across the country.
And this is where the rubber meets the road. This is where all these people that have worked on this program for a couple years, it culminates into the excitement of getting ready for what we call launch fever.
And so now, we get to kind of do some of the fun stuff, like put it on a giant airplane and take it to Kennedy Space Center, where we get to prepare it to go onto an Atlas V launch vehicle and launch.
It's the job of NASA's Launch Services Program to get GOES-S into orbit, and they have just a few months to do the final launch preps and inspections before T0 arrives. This is no easy task with a spacecraft of this size and complexity. In spaceflight, there are no second chances. A successful launch is resting on their shoulders. It has to be perfect the first time.
It's very exciting. I love being a part of this, and I love being able to contribute to the spacecraft and to its success.
GOES-S is the second part of a weather satellite upgrade project NOAA is undertaking, destined to save lives by modernizing our weather forecasting ability.
We have a very young team, and this will be their first campaign. So we're trying to put the excitement into that, let them feel what it's like to touch the spacecraft for the last time. Launch operations is time we all get together for one goal, which is launch.
But achieving that goal will not be easy. The road to T0 has just begun.
I watched our astronauts up in the space station on YouTube, how they function in zero-G to try to mirror some of that. The Peter Pan production, where you're hanging from wires. So basically what they did with me was just strap me up to the ceiling and then have me spin until I got nauseous to find out where that threshold was, so we wouldn't be doing that on set in a giant spacesuit. Well, it's hard to beat Armstrong's message, so good luck. I don't have any, I can't top that. Huh. I'll settle with the moon right now. I'm older, I don't want to be gone that long. I like my comforts. I'm going moon. If I was going to the moon, I get one item to take with me, I'm taking my music. Period. I think space is so fascinating certainly for cinema, because it's so unknown. There's so much we don't know. It's for one, our universe is ever expanding. It's infinite. I mean, these are concepts already that are beyond our understanding. It's wide open for invention. It's the great unknown, and how will it define us, and how will we define ourselves with it, that makes it so ripe for storytelling. Hey, I've got a few questions for NASA, if I may. First question, I was wondering, when are we going back to the moon? There's not water on the moon, is there? Really? Okay, I heard this rumor. There's something about water being on the moon. Could that possibly be true?
Thanks
Brad. We'll answer these questions and more in our new series, Ask NASA. If you have questions like Brad, use the hashtag AskNASA.
There's only one cargo ship designed to transport rockets for United Launch Alliance. And tonight, it's pulling into Port Canaveral with the robust flight hardware of an Atlas V.
We're a high-tech vessel, high maneuverability. We have to be because we get into some tight areas on shallow rivers. The Delta Mariner is unique. It has two aft Z-drives coupled by computer with the bow thrusters that turns 360 degrees on demand.
This crew has work to do. In less than 4 weeks, the rocket must be safely delivered, inspected, and assembled in order to successfully launch NOAA's highly advanced GOES-S weather satellite.
I sense from the crew the pride being part of this mission. And when I put this vessel alongside the dock, it is a very accomplished feeling that we all have.
The arrival of the Mariner is the start of operations for the flow of a rocket.
Teams from ULA and NASA's Launch Services Program start by unchaining the Atlas V booster and Centaur components, wasting no time in developing a plan and getting organized for transport.
We're going to take the booster over to the ASOC. It's going to be Convoy 1, it's going to be the leader, followed by the booster.
It's a very exciting day for the vehicle system engineers as we're offloading the launch vehicle that will carry the GOES-S satellite.
Here comes the Centaur second stage, with its pressurized stainless steel tank as thin as a dime. Unable to support its own weight until fully fueled, it's carried off the ship by a specialized trailer. Next comes the Atlas V booster, all 106 feet of it. This booster and 4 solid rocket motors have one job: provide enough energy at liftoff for the entire launch vehicle and payload to overcome the pull of Earth's gravity.
I never get tired of seeing the rockets come in. It's very exciting, especially on the Mariner.
Now on land, a challenging cross-base transport lies ahead to the Atlas Spaceflight Operations Center. Inside this multifunctional facility, crews will remove the protective coverings, inspect the hardware, and install the final flight components. For now, this mission remains a go, but the highly complex job of stacking the rocket is still to come. Dark 30, Cape Canaveral Air Force Station. With a full week of intense rocket assembly activities ahead, the teams from Launch Services Program and United Launch Alliance are getting an early start. It all begins with the booster. The booster is the backbone of the Atlas V, and literally everything is riding on it. It's the largest component and first to be lifted.
So Launch Services Program partnered with United Launch Alliance to select the Atlas 541 vehicle because it is one awesome rocket, and we need that thrust to get GOES-S to its geostationary orbit to meet its mission requirement.
It will take more than just the booster to get all the way to geostationary orbit. That's why we're adding 4 solid rocket boosters.
When you start with the Atlas booster, it's like 860,000 pounds of thrust with just the RD-180. So we need the solids for extra performance. We need it to get heavy payloads off the pad and for additional performance going to geosynchronous orbit or geotransfer. Mating the solids to the booster is a very hazardous operation. We have safety with us at all times. You have 100,000 pounds going up into the air and hanging on a crane. And oh, by the way, it's explosive.
Once the solids are mounted, it's time to mate the Centaur.
The Centaur is the upper stage, and it's tuned. It's like a highly tuned race car. It's light, it's efficient, it performs well for us.
We're out here to do the job and get it done right. If you see something that's not right, bring it up to us. Let's give us a chance to fix it, okay? All right, let's get in position to do this thing.
Assembling a rocket can make or break any mission. It takes tremendous coordination and skill to get this job done. The team makes it look easy, but rocket science never is.
The coolest part of my job is coming down here and seeing the hardware and knowing what it's capable of. We all get to work with rockets, and it's really exciting and fun, and everybody has their part in all of that. And yeah, when you're out with friends, you can say you're a rocket scientist. I do.
So there's really nothing quite like all the work and all the setup that we do to get ready to do this and get built up a rocket and tested to get to launch day. And when we get to T0 and the rocket lifts off and the control room rattles and shakes a little bit, it's an awesome feeling. That is the ultimate reward, and that's really what makes us happy, what makes our customer happy, is putting our customer where they want to go in the right spot, in the exact right orbit, and that is, there's a lot of pride in that.
This rocket is almost ready to roll. Of course, the only thing missing is its GOES-S payload.
We are NASA's preeminent science center. We execute NASA's most complex science missions, and we improve lives on Earth daily. Named for the father of modern rocketry, Dr. Robert H. Goddard, we are NASA's first spaceflight center. We began an era of spaceflight and innovation that is benefiting humanity and enhancing life on Earth. We are home to the nation's largest organization of scientists, engineers, and technologists who build spacecraft, instruments, and new technology to study Earth, the Sun, our solar system, and the universe. Our dedicated civil servants and contractors are modernizing Goddard's institutions and infrastructure for the future. We are transforming this facility into a premier science and research facility. I invite you to read our master plan, Envision Goddard, Modernizing for the Future. Learn how Goddard will meet the challenges of the future, exploring our planet and the far reaches of our universe, while inspiring the next generation of explorers and protecting our environment. We are Goddard Space Flight Center.
Two weeks to T0. Today is another huge milestone for NOAA's GOES-S mission.
So today we start something called encapsulation. By encapsulation, we actually put a container around the satellite. It's called a payload fairing. That payload fairing will protect the satellite for the first 3.5 minutes of its mission. It sounds like a very short period of time, but in fact, that's when we would have the maximum aerodynamic and acoustic loads on the satellite. So we're trying to protect the satellite. Right now, we really have tested everything we need to do to make sure this satellite is ready for launch. The next time we'll see this satellite is on orbit.
Shooting off the launch pad like a bullet, this vehicle will rocket past the speed of sound in just over 30 seconds. If not protected, the Earth's atmosphere will rip GOES-S to pieces. But for a satellite designed only to live in the vacuum of space, life on Earth can be just as dangerous. Any exposure to dust or moisture could contaminate the satellite and destroy the mission. That's why this fairing is more than just a suit of armor. It's also a portable clean room. With encapsulation complete, it's time to call in the KMAG. This 72-wheel transport vehicle is what it takes to get this massive payload to the pad.
Spacecraft hoist and mate to the launch vehicle today is a huge milestone for the whole operation. And this is the biggest integrated operation that we've had so far. And it goes all day, goes all night, from transport and then hoist and mate, and it'll go into the evening tonight as they finish closeouts.
After working through the night, LSP and ULA are almost there. Just 150 feet to go, straight up.
Obstacles, we do have obstacles on the decks, on the KMAG, so watch your step, walking area, trip hazards, and then remember about your hard hats, chin straps. Any other questions? All right, let's go do this.
There's a lot of moving parts involved with processing a spacecraft, processing a rocket, and then bringing them together for a launch. There are a lot of people involved and there are a lot of moving parts. We have a lot of hard timelines that we have to meet and deadlines that we have to meet, and everybody works as hard as they can to meet those deadlines, and sometimes we have to work around the clock to meet those.
We've reached a critical point on the road to T0. GOES is now mated to the Atlas V.
We've been working for several years integrating this thing and completed that now. We've got the satellite on top and we're ready to go.
With all major milestones complete, this rocket is ready to roll.
Engineer, proceed with MLP transport to pad.
Roger.
It's go time. The GOES launch window opens tomorrow. ULA and LSP have one last critical procedure to complete. Get the entire Atlas V stack and its mobile launch platform to the pad.
It is a fairly challenging activity if you think about moving a 1.5 million pound mobile launch platform and vehicle out to the pad.
Once it gets there, it will be loaded with rocket fuel and be ready to start the terminal count to T0. Years of intense planning and coordination are finally rolling to the pad, and the majesty of the Atlas V is on display as it inches its way to liftoff.
The thrill of seeing that Atlas vehicle, all 197 feet of it, rolling up to the pad, it's just really exciting because I know that means tomorrow is launch.
GOES is particularly important because of how it's transforming our capability to predict weather and protect lives and property. And I can't wait for it to launch tomorrow and become operational.
So great to be here after a number of years of seeing the spacecraft come together and all the instruments integrated onto the spacecraft. Our baby is tucked in and ready for launch tomorrow.
This is the LC on 1 performing pre-test briefing. This operation is classified hazardous. Cryogenics will be loaded. ALC verified. Verified. Proceeding with the count.
We're launching today, and the ULA team got on console a few hours ago, turned power on the rocket, and we are counting down to T0 right now. I'm on my way over to the ASOC, the Atlas Space Flight Operations Center, where the Mission Director Center and the Launch Control Center are located. And if the range is clear and the rocket is good, we're go for today. I love launch day. I'm so fortunate to work with a great team. Our team gets so incredibly excited to do missions, and it all culminates today.
Range coordinator, clear to proceed. Launch director, you have permission to launch. Proceeding with the count. ALC verified T0 is set for 2202 Zulu. Verified. Rock report range status. Range green. Status check. Go Atlas. Go Centaur.
Range Operations Controller reports range green. Everything is go.
7, 6, 5, 4, 3, 2, 1. And liftoff of Atlas V and NOAA's GOES, a highly sophisticated weather launching eye in the sky to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
It's just a thrill, especially when it all ends in launch success and mission success for GOES and this cutting-edge weather capability that our nation will now have.
Launching to space, of course, was a momentous experience, but oddly enough, it was quite familiar because of all the training we had. So those 10 minutes in the capsule riding the Soyuz rocket, there was the vibration, the pressure, the acceleration, the pressure in your seat. But after those 8 minutes of busy time and hyper awareness, if you want, of our environment, is when I had my first view of the Earth from space. The launch was at dusk, So quickly we entered penumbra and into night. And by the time we reached orbit, it was pitch black outside. And shortly thereafter came our first orbital sunrise during the rendezvous to ISS. And I will never forget that sight. The thin blue line of the atmosphere, the curve of the horizon. That's when it became real. Really, at a gut level, I'm actually in space. We are on orbit. This is not a sim. Because your mind tends to go the reassuring route of pretending it's just a game. But no, that this is reality. We are in space, in orbit. And that view, that sunrise, I'll never forget that. Through the crummy little side window of the Soyuz, still, it's amazing. It's like burned in my memory. I, of course, spent a lot of time at the cupola, looking at the Earth. And what has always struck me every time I went there is how beautiful the Earth is, how fragile it looks, how alive it obviously is with the clouds, the water. It's like it's breathing. The auroras, the presence of humans at night, it's obvious with the lights. But is the death around the Earth that's startling. How this beautiful, shining oasis of life is there naked in the middle of pitch black death, the vacuum of space. And then there's the dance of the celestial bodies around. The moon is there, but the moon is just a rock. The sun is just a ball of fire. And here's the Earth, this perfect oasis. So even though I knew this abstractly, like everybody does now, we have all seen those images, to see it with your own eyes, you develop that sense of awe. And also, you cannot go to space and continue, if you were, thinking that resources are infinite. They're obviously not. It's in your face. It's a finite system, a closed loop system. There's no new air, no new water that gets to Earth ever. It's all recycled and has been for billions of years. And it is perfectly balanced and perfectly matched to our needs. We are matched to her. That concrete realization that we belong to Earth and not vice versa, it's kind of a mental shift to see that we just nowhere else we could go. We can talk about colonizing other planets, but you know, kind of smarter and cheaper to just take care of Earth as she is. So that was very endearing, that vision. And I can close my eyes and always go back to the cupola looking at the planet. And that blue line, it's unbelievable. It makes the Earth look alive. She's glowing. Well, the little bubble we live in is tiny. And that was very, in a way, sobering perspective to get. How fragile, unique, and just sacred, really, our spaceship Earth is, and the responsibility we have to be good shepherds of her. It is the home of billions of humans and billions of other species, completely autonomous in the vacuum of space. It's just a miracle. You want to protect her because it is our only spacecraft. The whole of us, we're all astronauts, living in the deadly vacuum of space, kept alive by this beautiful, perfect machine.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind: the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
2014 is off to an amazing start as NASA rockets towards this year's launch of Exploration Flight Test 1. The Orion program began the year with several major milestones. The service module was completely finished in January at Kennedy Space Center in Florida. The service module is the part of the spacecraft that contains all of the structural elements, spacecraft adapter, payload fairings, and crew module separation systems the EFT-1 capsule needs to conduct its high-altitude orbital testing. In February, the completed service module was stress tested for the final time. The structural loads test proved that the vehicle will endure the physical stresses of its upcoming flight. After the test, the service module was ready to attach to the crew module. A test of the forward bay cover and parachute system was successfully passed in January at the Yuma Proving Ground in Arizona. After the Orion mock-up was dropped from a plane, the forward bay cover separated from the capsule, allowing the parachutes to release as the crew module descended safely to the desert floor. The capsule, parachutes, and forward bay cover were recovered and subjected to additional testing in the following months. In February, the Delta Mariner delivered 2 of the core and starboard boosters for the Delta IV Heavy rocket. After the boosters go through stringent testing and processing in the Horizontal Integration Facility, they will roll out to Launch Complex 37 for EFT-1's launch later this year. A full-scale mock-up of the Orion capsule was delivered to Langley Research Center in March. The mock-up will be used to perform a variety of static and impact tests to evaluate various water landing scenarios in a wide array of different conditions. At NASA's Kennedy Space Center in Florida, upgrades and modernization of the multi-payload processing facility continue as the building is readied for Orion processing support. By April of next year, the MPPF will have updated structural elements like environmental control systems, high bay doors, and emergency systems. The facility is also upgrading spacecraft preparation elements such as fuel and breathable gas systems, time-critical installation equipment, and ground support equipment storage. In January, the Crawler Transporter 2 completed a test drive on new traction roller bearings in 2 of its truck sections. The new roller bearings are one of several upgrades to the Crawler Transporter, which will carry the significantly heavier Space Launch System out to Launch Pad 39B. The other 2 truck sections of the Crawler Transporter will also receive new roller bearings and complete a follow-up test drive in November. In February, NASA and the Navy tested procedures to be used during Orion recovery operations. After launch and re-entry simulations, the forward bay cover and parachutes were successfully retrieved from rough waters off the California coast. The ocean turbulence in the well deck of the recovery ship made it difficult to secure the Orion test article. The challenges experienced during this test reinforced the necessity of practicing spacecraft recovery. The circumferential dome weld tool produced a second liquid oxygen tank confidence article at the Michoud Assembly Facility. The confidence tank verified that the weld tool is capable of producing the core stage tank up to the exacting standards the Space Launch System will require. A composite cryotank for liquid hydrogen was also produced and delivered to Marshall Space Flight Center aboard NASA's Super Guppy cargo plane in March. The advanced composite cryotank, which could benefit many of NASA's deep space exploration spacecraft, will undergo a series of structural pressure tests later this year. A scale model of the SLS was used in acoustic testing to see what effects high and low frequency sound waves will have during launch. The model's core stage fired for 5 seconds while an array of microphones collected the acoustic data. A full assembly test with the scale rocket motors will be conducted later this year. In March, NASA Administrator Charles Bolden visited Marshall after the software integration team powered up the flight avionics, which includes hardware, software, and operating systems for Space Launch System. Known as First Light, the flight computers of the SLS simulated the flight path the vehicle will experience during launch. NASA's Exploration Systems Development Division is flying through production, testing, and launch, as 2014 promises to be one of the most productive and exciting years in recent space history. Halfway through one of the most productive years in recent space history, NASA's Exploration Systems Development Division is moving humans ever closer to deep space exploration. The Space Launch System, NASA's next-generation deep space launch vehicle, had an intense spring full of development and testing. Testing on the avionics system, responsible for controlling the Space Launch System's solid rocket boosters, began in April. The avionics system will ignite, steer, and jettison the two solid rocket boosters, and will continue to undergo an extensive series of tests this summer. In May, structural tests on the SLS booster forward skirt proved it could withstand millions of pounds of launch stress during a series of ground tests. The SLS core stage will be powered by 4 RS-25 engines that are now undergoing preparation for test firing at the Stennis Space Center in Mississippi. Following initial testing, the engines will be integrated with the core stage, and the entire assembly will be tested on the B-2 test stand. Because the SLS core stage is 50% longer than the Saturn moon rocket stages, the mothballed B-2 test stand and the main derrick crane are currently being modified and upgraded to accommodate this enormous structural element and powerful main engines. Production on the core stage structure and propellant tanks continues at the Michoud Assembly Facility in Louisiana. 34 primary structure components and 20 rings have been welded to build the core stage propellant tanks, including 9 barrels and all the rings needed for SLS's first flight. A 5% scale model of the SLS was ignited to test how both low and high frequency sound waves will affect the rocket as it fires its solid rocket boosters and main engines on the launch pad prior to liftoff. These ongoing tests are collecting data from over 200 sensors to study the acoustic impact on the spacecraft and verify the design of its water-based sound suppression system. A major milestone in the effort to transform Kennedy Space Center into a multi-user spaceport was met when Ground Systems Development and Operations completed the initial design and technology phase of the preliminary design review. GSDO is modifying the spaceport's infrastructure to support several different spacecraft and rocket launch needs. Firing Room 4 at the Launch Control Center at Kennedy Space Center in Florida is being renovated into 4 separate launch areas to serve NASA and commercial users' needs. Designed to accommodate a multi-user spaceport, the new adaptable rooms can open up to give more space as needed by a customer's launch room parameters. Upgrades to the mobile launcher at Launch Complex 39 are underway, with significant progress toward advanced usability. GSDO is systematically modernizing the launcher to meet the increased needs of the more substantial Space Launch System. Upgrades include structural work, an improved sound suppression water system, a redesigned exhaust opening, new data connectivity to the Launch Control Center, and updates to the power, air condition, and fire alarm systems. After the Exploration Flight Test 1 mission is complete and the capsule lands in the Pacific Ocean, the Ground Systems Development and Operations and Orion programs and the U.S. Navy will retrieve the capsule and ship it back to Florida for reuse. The return process requires a series of pre-transportation operations, which were successfully tested in May. Workers practiced assembling a transportation fixture that will be used to move future Orion crew modules across the country. The newly renovated Flight Control Room at the Johnson Space Center in Houston played host to members of the media and top NASA officials in April. The White Flight Control Room will support the Orion spacecraft during NASA's deep space exploration missions. In May, the room was used in a joint integration simulation, along with a team at the Kennedy Space Center in Florida. The two teams simulated the pre-launch and in-orbit phases of Orion's mission and solved real-time problems, acting as the eyes and ears of the uncrewed spacecraft. The rigorous testing on Orion's parachute system continued in April and June, proving the parachutes are capable of surviving potential failures during both re-entry and launch abort scenarios. The first test simulated an abort scenario by dropping the capsule from a height of 13,000 feet and releasing the main parachutes before the drogue parachute could deploy or the vehicle could straighten itself out. The second test pulled the capsule from the C-17 airplane at an altitude of 35,000 feet, with one of the main parachutes intentionally rigged to skip a crucial phase in the unfurling process. Both tests demonstrated the parachute system can tolerate unexpected failures and still carry the capsule safely to the ground. After 2 years of intense production and testing, Orion's massive heat shield was successfully attached to the crew module in Kennedy Space Center's Operations and Checkout facility. The 16.5-foot wide ablative shield will protect the capsule from re-entry temperatures of up to 4,000 degrees Fahrenheit. A center of gravity test confirmed that all of the ballast was properly installed in the crew module. The test validated the Orion team's computer models used to calculate the amount and location of ballast needed to properly balance the crew module. With the heat shield securely attached to the capsule, the crew module was then stacked on top of the service module in June. The stacked modules will undergo electrical, avionic, and radio frequency tests to prepare for the Exploration Flight Test 1 in December. In May, astronauts at the Neutral Buoyancy Laboratory in Houston trained underwater in newly modified spacesuits to work through simulated operations for NASA's asteroid retrieval mission. A month later, a naval team worked with Orion recovery specialists to train for a set of procedures to safely retrieve the capsule and forward bay cover. As Exploration Systems development closes in on December's launch of Exploration Flight Test 1, NASA centers nationwide stride toward the moon.
ISO. Go. Weather. Go. Pointing. Pointing scope. CDH. Go. GNC. Go. Ecom. Go. Inco. Go. NGC. Go.
Engine start box, go.
Rock report, range status.
Range green.
Upper stage LH2 securing flight level. Status check.
Go Delta.
Go Ryan.
5, 4, 3, 2, 1.
And liftoff at dawn. The dawn of Orion and a new era of American space exploration.
Flight Fighter. Go Fighter. Yes, sir. Just passed through apogee. The altitude was 3,132 nautical miles.
Station, this is Houston. Are you ready for the event?
Houston, this is Space Station. We are absolutely ready for the event.
SpaceX, this is Mission Control Houston. Please call station for a voice check.
Station, this is Benji Reed from SpaceX. How do you hear me?
Hello, Benji. We hear you loud and clear. Welcome to the space station in virtually and physically.
Thank you, Chris. It's an honor to join you guys today. And it's awesome to see all of you guys up there together. First, I just want to say thank you again to Bob and Doug and your families from all of us here at SpaceX, all of our locations, all of our partners, all of our vendors, everyone for trusting us to bring you up there. I hope your first day there has been great so far.
Hey, thanks, Benji. It's same back at you. You know, congratulations to the folks out at Hawthorne, McGregor, and at Kennedy. Just an incredible journey we've had the last couple days. A great day in space today, our first day of work on Space Station. But what a great ride on Dragon and Falcon 9 to get us here. Everything worked exactly the way we planned it to work, and that's a credit to the teams there in Hawthorne and McGregor and Kennedy. Just it's a pretty awe-inspiring trip so far, and very humbling, and just we're just so proud to represent SpaceX and NASA in this new next launch capability.
Absolutely. It's excellent to hear your voice, and it's excellent to just see you guys up there floating around and spinning Earth and doing all these great things. A number of our employees have asked questions that we'd like to throw your way here. Probably the first one, and you've had this in a different version before, but what did it feel like riding on Falcon 9?
All right. You know, we certainly have talked about it, but it never gets old talking about riding on Falcon 9. Just from the time the engine's lit, the first 2.5 minutes to staging was about like we expected, except, you know, you can never simulate the G's, so as the G's built, you could certainly feel those. Also, what I thought was really neat was how sensitive we were to the throttling of the Merlin engines. That was really neat. You could definitely sense that as we broke Mach 1 and went transonic and broke Mach 1. We could definitely feel that. In fact, I said it to Bob, and then the next thing you know, the call was made, and we didn't even need to look at the speed. You could tell just by how the rocket felt, and so it's a very pure flying machine. And then I think the next thing that really stood out for me was first stage separation with the engine cut off, and that separation event going to 0G for a split second, and then the Merlin vacuum engine lighting. That was a pretty neat event. That was a highlight of the ascent for me. And then once the MVAC started, then it was that kind of driving fast, very fast on a gravel road is how it felt the rest of the way up. A little bit of vibrations, not anything that was really unpleasant, but you certainly knew that there was a powerful engine behind you at the time, and that obviously took us all the way to orbit about 6 minutes later. And once again, you know, the G's and how the engine throttled to control the G's, and then straight to cutoff, and then just like with shuttle, you go from 3, actually in this case we were more than 3 G's to 0 G's instantaneously, and we knew we made it to orbit.
That's awesome. Sounds like the ultimate ride in a Batmobile with the jet engine turned on. Another question that we had came about what was going through your mind when you were on the pad. We know that you guys are steely-eyed and focused on the operation, but what was some of the last things that you were thinking about just before launch?
I think for both of us, Benji, we really almost started the ride when we got to go for tanking. And so when the tanking operations started, you know, Dragon really and the Falcon 9 really came alive underneath us. It was a little bit different than our shuttle experience where we came to the vehicle after it was tanked. And so as we marched through the loading countdown, I think when we got to 16 and a half minutes and we got started on the locks for the second stage, I think that we said, well, we haven't done this before because it was something new from what had happened just a few days earlier. And I think each one of the events, we just marked them off as, oh, we never did that before. Oh, we never did that before. And it was pretty cool kind of marching our way all the way uphill. And so all the way to the point where we saw 189 or so on the perigee, I think, and knew that we had safely made it into the first portion of our orbit and we're headed towards space station. I think we were excited, but I've said this before, and I'll say it again about the training team, just doing an excellent job. And when we started this adventure, I described it as my goal to make it like Groundhog Day. So it was very familiar as we marched through the various events, and we knew where to look next for the thing that was going to tell us that we were proceeding normally through the count, through the launch, and on into orbit all the way to space station. And they succeeded wonderfully in producing that desired Groundhog Day familiarity as we went through the launch count. And of course, there's plenty of excitement when you ride a rocket, and we prefer the term as Demo 2, Dragon drivers versus Dragon riders. But when you go through that, there's certainly a ton of excitement to go along with all that as well.
That's fantastic. It sounds great. And we appreciate how much time you spent with us doing all of that training to make it Groundhog Day too. A question for Chris. What was it like for you knowing your buddies were going to be coming back, these Dragon drivers were going to be showing up, and then opening the door for them?
You know, Benji, it was really cool. As I was sitting in the cupola looking out the window, I had the opportunity to take a few photos. Hopefully you've seen some of them. They turned out pretty nice. But I could see the docking mechanism, and with a big lens I could really look at the intricacies of the hatch and the docking mechanism. I thought about all of you folks there who put that together, and those mechanisms that were just moments away from making the physical contact and making these two vehicles one. And it really represented, as silly as it sounds, those docking mechanisms represented to me the unity that now we have between SpaceX and NASA.
That is really cool symbolism. It's true. You got that sense as we were moving into hard capture that you're becoming one vehicle. And you know, part of that unity that we see, you guys have a picture of the Earth, and you have a flag which also represents the friendly competition maybe that brings us unity. Why don't you tell us about that there?
Yeah, so this is the flag that we left here almost 9 years ago on STS-135. It had actually flown on STS-1, and then it flew again with us on STS-135. And at some point after the end of the shuttle program, we decided we would have a little friendly competition to see who came up and got this flag. And congratulations, SpaceX, you got the flag. So Bob and I, Chris will not let us forget it. That's the biggest thing, is this will be on his to-do list when we get the nod to return Dragon back to Earth, and hopefully this will find a great place of honor somewhere in Hawthorne.
Well, it's an honor to have you guys be able to come grab that flag. One other question that we got was if anybody has seen Little Earth floating around, or maybe he's driving the space station, or...
Yeah, that's a great question, Benji. I haven't had a chance with, Chris is going to go find him. We haven't been on station long enough to finish all the activities that we've had to do with outfitting Dragon for, being able to be our emergency lifeboat home. So we spent the day doing that. And we're really excited. This is going to be the event. No one else is getting a chance to see this, I guess. Yeah, here comes Earthy. And I think I might need to run down and get Tremor, the Apatosaurus, so that we can reunite these two together. So our intent is to bring Earthy home if we can fashion a spacesuit for him so that, he needs emergency response or she needs emergency response capability as well.
That's outstanding. Very good. I want to give you guys a chance. I hear there's something else that you guys wanted to talk about or show us.
Yeah, this is that mosaic that was put on board Dragon with all the virtual graduates this year that you guys put together, and we think it's amazing. I know Chris, when he first saw it, said he couldn't believe how cool it looked, and we just wanted to make sure you guys got to see it here on board Space Station.
That is very cool. I understand that over 90,000 graduates from preschool through college and graduate school for class of 2020 are represented on that. And there's Tremor.
No, I think that this image that you guys put together to recognize the class of 2020 with all that the entire Earth is going through, I think as astronauts, we often get asked the question about the overview effect and the perspective change that happens. And I think things like the pandemic that we're all going through together should make it clear that we're all in this together, and kind of cooperation and doing your part to fight the battle that we're fighting against this pandemic. This is just a great example of the same sort of a thing, that we're all going through this shared experience. And it's just wonderful you were able to recognize all the graduates in this special way.
It's wonderful, guys. I just want to tell you again how awesome, and honestly gives me goosebumps just to know that I'm talking with you as you're on orbit above us right now. It's awe-inspiring for all of us. And so maybe one last question. What would you tell the future generation? We've got a lot of us have kids. A lot of us are have family and friends who are going to be the next generation of astronauts. What would you say to all of them?
For me, I would say dreams do come true, and you should chase them. I think when we had our short meeting with Elon the other day in crew quarters, we talked about the audacity that it takes to pull off human space flight, and how much paranoia that it also takes to pull it off. And, if you work really hard, you can accomplish great things, and this is just a true example of exactly that. Folks not giving up, whatever challenges are in front of them. It's been... folks talk about SpaceX as being a new company, a new kid on the block. When we talked to Hans the other day, he shared with us his 18-year story. So it's almost unfair to call yourself a new kid on the block anymore once you've made it to low Earth orbit with humans and have 18 years invested. So just hats off and congratulations to you guys for accomplishing it. And you accomplished something great because you dared to dream it.
Well, thank you guys, and on behalf of all of us here at SpaceX and all of our partners, thank you for flying SpaceX. We look forward to bringing you home soon to your families, safe on Earth, and then sending more people up to help keep Space Station running. Thank you for your time today.
Thank you, Benji. Thank you, Hawthorne. Thank you, McGregor. Thank you, Kennedy.
Station, this is Houston ACR. That concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station.
Thank you to all participants from SpaceX. Station, we are now resuming operational audio communications.
Hi, my name is Dr. Emily Schaller, and I'm here at NASA's Wallops Flight Facility on the eastern shore of Virginia. We're here because NASA is using airplanes to study hurricanes. The mission is called HS-3, which stands for the Hurricane and Severe Storm Sentinel. What's a Severe Storm Sentinel? It's actually a remotely controlled airplane called the Global Hawk Unmanned Aerial Vehicle, or UAV. Pilots fly the plane from a cockpit on the ground. NASA is using these Global Hawks to study hurricanes in the Atlantic Ocean by flying over and around them. The Global Hawk can fly for very long periods of time at very high altitudes. It can fly almost twice as high as a commercial jet, and it can fly for over 24 hours without stopping. That's why scientists are using the Global Hawk for the HS-3 mission, so they can continuously study storms as they develop. Forecasters have a pretty good idea of where these storms go, but what they want to know is, will they grow? We spoke with NASA mission scientists about how the Global Hawk will help improve their understanding of hurricane formation and growth, and why it's so important for us to learn more about hurricanes.
The Hurricane and Severe Storm Sentinel has a goal to try to better understand the processes that control the intensity of storms. The ability to predict the intensity is very important because it impacts people in the coastal zones who, if they're anticipating, say, a tropical storm, a Category 1 storm, and they end up getting a Category 3 storm, it makes a big difference in terms of their ability to prepare and deal with the storm consequences.
And this is really important because a category of a hurricane is the intensity of the winds associated with a hurricane. So a Category 5 hurricane is much more destructive than a Category 1. So being able to predict the difference between just a tropical storm, a Category 1, up to a Category 5 is really, really crucial to saving lives and lessening damage and so forth, particularly saving lives.
The benefit of HS3 compared to any other hurricane mission is the fact that we have these planes able to fly upwards of 24 hours, and being able to monitor a storm for that long period of time and getting constant data, we can actually catch changes in the storm.
We will use 2 Global Hawks. One Global Hawk flies over vast areas around a hurricane. It measures the environment that a hurricane is embedded in. And then the second Global Hawk, instead of sampling the vast area, it goes right in to look at the eye and the eye wall and the inner core processes of a hurricane.
The Global Hawk unmanned aerial vehicles flown by NASA were originally built for the military and used for flight testing at Edwards Air Force Base in California. When the Air Force was done testing these models, they were transferred to NASA, which turned the planes into airborne laboratories to study the Earth. NASA flew its first science mission with the Global Hawk in 2010.
The Global Hawks are really a new aircraft for doing hurricane studies. Manned aircraft typically fly for, say, 8 to 10 hours when they do a research flight. Of that 8 to 10 hours, you may have 4 hours or more just getting to and from the storm, so that in a typical flight, you only get 4 to 6 hours actually sampling within the storm. With the Global Hawk, we can get 3 times, sometimes even 4 times as much as you can get with manned aircraft.
Now this plane can fly to 65,000 feet. It can fly 13 miles up. It can also fly for nearly 30 hours. So this plane can take off here from Virginia, on the coastline of Virginia, close to where hurricanes form. It can fly all the way to Africa. It can spend about 10 hours on the coastline of Africa and then fly all the way back. There's no plane that can do that in the NASA vehicles that we have.
Because the Global Hawk can fly so high for so long, scientists can study larger areas of the Earth for longer periods of time, in places where planes with pilots on board may not be able to reach. We spoke with pilot Phil Hall about the Global Hawk and what it's like to fly the plane without actually being inside it.
So the 2 Global Hawks that we're flying for HS3, Air Vehicle 6 and Air Vehicle 1, from a pilot perspective, it's a very different aircraft. We don't have any rudder pedals or a control yoke. We actually use a mouse and keyboard. We actually have a control room on the ground. We have 2 of them now. We have one at Edwards Air Force Base in California, and we have one here at Wallops Flight Facility in Virginia. So it's basically like a trailer. It's been specially designed for Global Hawk. It's full of computer systems that can talk to the aircraft. So we can connect to the internet, and all these satellite products of lightning, the storm from satellite images, we're able to download that almost real time and use that to actually navigate the storm. For the first part of the mission, we actually fly the aircraft from Wallops. And once we get about 2 or 3 hours into our flight, we actually transfer control of the airplane back to Edwards Air Force Base, NASA Dryden Flight Research Center. It's very different from any other kind of aviation operation in that we have pilots on both coasts, and we can actually transfer control of the aircraft during the flight to the other pilots. And when you have these long missions, like 26 or 27 hours, one person can't sit there for the entire flight. So we actually have 3 or 4 shifts of people that come and go to man this aircraft.
Now, pilots know how to fly planes and they can tell the plane where to go, but how does a pilot actually know where to go? You have to have scientific information. Now, the scientists sit in a separate trailer. We have computers sitting in front of us. We bring in satellite information. We bring in forecast information. And because weather can change so fast, they can collect that information, interpret it, and then relay it to the pilots and say, well, instead of going over to this point, why don't you go over to this point over here, which is where we think the eye has relocated. So it's a great team between the scientists and the pilots to actually get the most information you can out of a flight.
How can you become involved in our mission? You can follow the plane too, just like the pilots and scientists do, by participating in live chats where you can get live updates on where the plane is flying right from your own classroom.
You can definitely be a part of our mission by actually being able to look at the same screen we're looking at. I'm looking at where the plane is flying with respect to the storm, and you have access to the same data I get to look at. You have access to see the plane's altitude, you can see the wind speeds, you can see the wind direction, and you can chat live with pilots, with forecasters, mission scientists, and we're looking at the same thing you are, and that's just really exciting to know that you can ask us any question at any time, and we are right there looking at the same thing.
To learn more about our mission, visit nasa.gov/HS3. See you next time on NASA Airborne.
Wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
And there it is. You're looking at the American-made rocket and spacecraft that will return American astronauts to the International Space Station from American soil for the first time since the retirement of the space shuttle, last flown nearly 9 years ago. Today, we're giving it another shot with our partners at SpaceX. Wednesday's first attempt was postponed due to that wild weather. But if all goes well today, we will mark a new first in NASA's storied history and usher in the commercial crew era of American spaceflight.
At 3:32 Eastern Time this afternoon, NASA astronauts Doug Hurley and Bob Behnken are expected to lift off from Pad 39A aboard SpaceX's Crew Dragon spacecraft atop a Falcon 9 rocket. If the weather cooperates, today's attempt will mark SpaceX's first ever flight with crew and the beginning of a new chapter in human spaceflight.
Good afternoon and welcome back to Kennedy Space Center, home of the wild Florida weather, which is why we're sitting inside again today, but this time a little bit closer with some plexiglass between us.
Yes, and I'm Lauren Lyons, a senior Starlink development engineer at SpaceX, and joining us today is retired astronaut and NASA meatball lover, Leland.
Thank you, Lauren and Marie. It's great to be back. That weather was really wild last what, 2 days ago, 3 days ago?
Yes, it feels like yesterday. I don't know if depending on how much you slept, could be the same day.
I
but I think it was Wednesday.
But down to T minus 17, and our teams made the right call. You know, we didn't want to go through that weather and have something happen. And I think that, you know, we're back to this hollowed ground thing, Pad 39A. We are, you know, my time back there was in 2008, 2009 on Space Shuttle Atlantis, launching to the International Space Station and building out the International Space Station. So now Doug and Bob can launch Crew Dragon and go to an assembly complete space station.
Yeah, and I know it's been really touch and go with the weather. We were looking at it last night. We're looking at it this morning. The teams are going to continue to monitor things. So it's kind of touch and go. But at last check, it was a 50-50 chance. So hopefully those odds are going to be, I don't know if they're going to improve, but 50-50 is not bad. It could be worse, right? So we have teams all over the country covering the action from SpaceX headquarters in California, Mission Control in Houston, and our social media desk in Washington, and of course, right here in Florida.
Today's mission will be Crew Dragon's second test flight and its first test with humans on board. We're a little more than 4 hours away from liftoff. Bob and Doug have had their lunch and have completed their medical checks in advance of launch. In about 15 minutes, NASA is going to turn the crew over to the SpaceX team. And once that happens, there are a series of key milestones to complete as we count down to T0. The first one is suit up. Now, the suit-up room is located in NASA's Neil Armstrong Operations and Checkout Building, or the ONC. Here, the SpaceX team is going to help the astronauts put on their suits and perform key suit checkouts. From there, the next step is crew walkout. The astronauts are going to leave the ONC building for final goodbyes with friends and family gathered outside of the facility before they head out to the launch pad.
And following final goodbyes, the crew will get in a Tesla and begin the roughly 20-minute drive to pad 39A. Now, once at the pad, the crew will ascend the fixed service structure in order to board the spacecraft in a process we call crew ingress. During ingress, the SpaceX team will run a series of checks to ensure the suits, seats, and the vehicle interactions are all functioning properly.
And after all the vehicle and crew checkouts are completed, the SpaceX closeout team will close Dragon's hatch with Bob and Doug safe inside. About 40 minutes before launch, the crew access arm, which is that long suspended walkway that the astronauts are going to use to board Dragon, it's going to retract away, followed by the arming of the launch escape system.
Once the arm is retracted and the escape system is armed, that's when propellant loading on the Falcon 9 rocket will begin. About 5 minutes before liftoff, Dragon will be configured for what we call terminal count. This is when Dragon's onboard computers take control of the vehicle.
And at T0, again, a little over 4 hours from now, if all goes well and the weather cooperates, Crew Dragon and Falcon 9 will lift off from pad 39A, carrying astronauts Bob Behnken and Doug Hurley. Roughly 12 minutes after liftoff, Dragon will separate from Falcon 9's second stage, enter its activation phase, and begin using its own onboard propulsion system to carry Bob and Doug to their destination, which is the International Space Station. And as I mentioned previously, Bob and Doug are just finishing up their lunch, and we are currently awaiting their arrival to the suit-up room.
And while we await that, you will notice over the course of this broadcast that we do not have crowds gathered here at Kennedy Space Center. And that, of course, is one of the impacts of our protocols to protect each other and our teams. We would normally have tens of thousands of guests here at the Kennedy Space Center in Florida to view the launch. But even though we couldn't host a lot of guests here, you can still join us through every step of this historic mission from wherever you are. We have a team dedicated to those of you following along on social media, and NASA's Tahira Allen is in Washington right now leading that effort. Hi, Tahira.
Hey, Marie. And hey, everyone out there. My name is Tahira Allen. And if you are one of the 4.9 million people tuning in on Wednesday, we are so glad to see you here again. If you weren't able to witness the pre-launch activities on Wednesday, you are in luck because I'm here to bring you all the excitement happening on social media around the nation. This is a big day for both NASA and SpaceX, and we are ready for you to be a part of it. We had a lot of people engaged on Wednesday, so we want to see if we can top that energy today. We will be sharing your photos and thoughts live on air during today's broadcast, so don't hold back and show us how you're getting ready for liftoff. You can join the conversation by using the hashtag LaunchAmerica on NASA's Facebook, Twitter, Instagram, and LinkedIn. I'll be monitoring that hashtag LaunchAmerica all day to highlight your social media posts throughout the show. You'll also be able to engage in social media polls during today's broadcast. And so even if you tuned in before, these are brand new polls, so just head on over to NASA's Twitter to cast those votes. So I know most of you are tuning in from home today, but that doesn't mean you can't get involved in the action. Check out NASA's Instagram and Facebook to find our Launch America augmented reality filters. They place you right at Kennedy Space Center, and you can actually see the Falcon 9 rocket lift off in a pair of sunglasses. If you haven't already, be sure to check out our first ever global NASA social. So head on over to NASA's Facebook to join the group. We've got all new social badges, a nice fresh photo here, some Q&As with some very special guests, and also behind the scenes tours of Kennedy Space Center in Florida. And not to mention just an awesome community of people excited to witness this moment. So just right here in training, getting ready for that Launch America. So if you're just tuning in, to get us started, we have a poll for you on Twitter right now. We want to know what NASA logo you are sporting for today's launch, the iconic meatball or the iconic worm. Head on over to NASA's Twitter to cast those votes. And with that, let's head back to Lauren at Kennedy Space Center. Lauren?
Those are the doors at the back of the crew quarters building, and it's an area where family, friends, and members of the media can share one final moment with the crew before launch. Now, the walk through those doors has signaled the beginning of the march towards launch for every American mission to space since 1968. This is the moment that is immortalized on film and video for 400 different astronauts from Apollo all the way through Space Shuttle, serving 150 total missions, and soon, if the weather cooperates, mission number 151 with the first 2 commercial crew astronauts. These doors carry with them a legacy of purpose and action, and today they will announce to all of us the start of this, NASA's SpaceX Demo 2 mission.
And you saw just a little bit of my walkout from STS-129, my last mission. And I remember having my friends and family out there. There was my chemistry teacher that was in the crowd. She got me turned on to science and helped me actually become an astronaut. And I just remember her being in the crowd saying, "Go Leland!" And it was just such a memorable moment for me. It kind of got more rocket fuel in my veins, getting me ready for my mission.
Yeah, absolutely. And we were just looking at a live picture outside of the building where we could see some of the folks gathered. We could see Doug and Bob's immediate families. There's a small contingent of media there. I mean, normally that place would be just kind of jam-packed with as many people as we could fit in there to capture that moment. We, of course, had to scale that back a little bit to maintain social distancing, but there's still a very excited group of people standing outside the building right now waiting for that to happen.
Yeah, it's so cool to see their families there and that they have that moment with them prior to getting inside of the Teslas. I mean, seeing that the last time we made that attempt was this incredibly emotional moment. I have no doubt it will also be emotional again. But yeah, that I can only imagine what's going through their heads, in that moment when they're just waving goodbye for the last time before flying. I mean, Leland, were you nervous? Were you?
At that moment we were, we had been a little jovial in the suit up walkout, but I think at that moment we're thinking about our families, leaving our families, but then at the same time, we're going to do this incredible thing for helping advance our civilization. We are working as a team, all the other teams now with SpaceX and NASA and people all around the world really, in recovery and all these things, helping us get to space so we can advance our civilization. And I think those moments are really heartfelt for us, that a team of people have helped us get to this point.
Absolutely. And we are looking at a live picture now of Bob Behnken and Doug Hurley walking down that hallway in the astronaut crew quarters. We just saw Doug wave at the screen, and they're just turning the corner, getting inside that elevator. And this, you can't see it from here, but there is a banner hanging there. You can kind of see it in the back. There's a banner hanging on the wall of the elevator with the signatures of all the people who worked on this mission. So it was really important for them to hang that up in there so Bob and Doug could see it.
Yeah, we see that, and we see all those signatures of people that have helped us through training, through fit check, through all of these moments and getting ready for this mission. And it feels like they're going along with us on the ride.
Absolutely. And as we wait for the crew to come downstairs to the first floor, we will pause to honor today's efforts with our national anthem. Kelly Clarkson just blew us away with a fantastic rendition Wednesday. Here she is again.
Say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we and the rockets regular, the bombs bursting in. I gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Oh, I got goosebumps listening to that. I mean, it doesn't get old. We heard it Wednesday, but I mean, I could hear that every day of the week.
She was blowing.
Yeah, amazing. That's a live look again at Launch Complex 39A. We are awaiting astronauts Bob Behnken and Doug Hurley to walk out of the Neil Armstrong Operations and Checkout building any minute now. So we're going to be ready to cut to that shot just as soon as we get the word that they're ready to walk out that door. Those doors, excuse me. Again, looking like it's been a beautiful start to the day here on Cape Canaveral, but we're keeping a close eye on weather because it looks a little iffy as we get later into the afternoon, closer to launch time, which again is 3:22 this afternoon.
It always blows me away every time I visit Florida is, 1 hour it's this beautiful, clear, gorgeous day, and then an hour later it's a thunderstorm.
You said it. Welcome to our world.
And then an hour later, it's back to clear.
Yeah.
Yeah.
Wow. Just similarly to last attempt, right? I mean, just 15, 20 minutes later, it was good to go.
I know, it hurt my soul because we have this instantaneous launch window. It's not like with shuttle where we could give it a couple more minutes because you had a 10-minute window. We have a single second to get this off the ground. So everything's got to be just right. The conditions all have to be green at that moment.
Again, Mother Nature showing she's in charge.
Absolutely. And we just heard we're about 30 seconds, less than 30 seconds now from seeing the crew walk out of those doors. So we are standing by to show you that moment live. There's a live look at the ONC walkout doors.
Marie, I think my STS-129 patch is still over top of the door. There's a bunch of patches up there unless they've removed them and put space station patches up there. But this is a very solemn moment for walkout from, a storied legacy of Apollo and seeing Apollo astronauts walk out of these doors. And now we're getting back to U.S. astronauts launching from American soil, walking through these doors again. It's an incredible moment in the era of space travel.
And we saw some just beautiful moments when they walked out on Wednesday, and looking forward to seeing those again. I was perusing all of the different newspapers and stories online and just taking in all the photographs, and there the doors are opening.
Here they come.
Great.
And there they are, NASA astronauts.
Small crowd, but big cheers.
NASA astronauts Bob Behnken and Doug Hurley, Doug on the left, Bob on the right, waving to the crowd there to cheer them on. And there are their families right in front of them.
The virtual hugs, a very special moment. Fist bumps.
Are you going to be on good behavior? Are you going to listen to mommy and make her life easy?
You can hear them.
Ready? Let's light this candle, I agree. Launch America! Bye, guys.
Now they are getting into the Tesla Model X that's going to take them to the launch pad, being strapped into their seats.
Their suit techs are attaching their umbilicals, so integrated into the Teslas. These are not just any Tesla you can just buy off the web or in a Tesla dealership. They've been outfitted with cooling units, and that white umbilical, similar to what you saw in the suit room, that umbilical is being connected to the suit to provide cooling air to the astronauts while they're on the way to the pad. And those Falcon wing doors are closing.
Super sleek.
A rapid departure from the Astro van.
Yes, I would say so.
And their flight surgeon is in the front seat in the passenger side, taking the journey along with them.
As I mentioned last time, we always think about the technology and the rockets, but this is what it's all about, the families coming together, supporting the families, us working together as a team to ensure they get up there safely and back home safely for their families.
I couldn't hear everything they were saying, but I did catch Bob telling his son to be good for mom and make her life easy. As a parent, I appreciate that.
Let's see that prominent NASA meatball.
Now, as we watch the convoy begin their journey to Pad 39A, to our SpaceX and NASA family who over the years made this mission a reality and who have worked this launch campaign up to this point, we have you here in our thoughts.
And we wish every one of you could be here to see this up close. But we want you to be part of this journey regardless of where you call home and regardless of where you're watching from today. And so for the next few minutes, we are going to follow the convoy, but highlight those whose words and hands and thoughts built all that we see here today. We hope all of you watching can feel the pride each of these NASA and SpaceX team members has for this drive out to the pad.
This is Laura Segura from the Commercial Crew program. We're so excited about this historical day. Congratulations on being a part of the very first mission for human spaceflight, commercial human spaceflight ever. We're behind you, Bob and Doug.
I'm Nicole from SpaceX in Cape Canaveral, Florida. Congratulations to SpaceX for hitting another major milestone, and safe travels to Bob and Doug.
Bob and Doug, as the launch vehicle chief engineer, we've got a lot of our launch vehicle team here to wish you a very wonderful and safe ride on a Falcon 9 coming up to Demo 2. We're so excited for you. And Launch America, it's time to launch. Let's go. Launch America.
Hi, this is Perla from Hawthorne headquarters. We want to wish Bob and Doug a safe trip to the International Space Station. Go Dragon!
It's been 9 years in the making. This is such a historic time, and our team has worked so hard, and we're very excited to be here. Go Bob and Doug!
Hi, this is Sam from McGregor, Texas. Go Bob and Doug, go NASA, and go SpaceX.
Sean O'Rourke from Johnson Space Center. Bob and Doug, wishing you a great flight. I just wanted to tell you good luck.
Hi, I'm Dustin Kamak with NASA Kennedy's Communications and Public Engagement Directorate, and we all want to wish Bob and Doug safe travels and Godspeed. You are both an inspiration to us all. Now, let's get out there and launch America. Let's do it. Come on, launch America.
I love seeing that group of people. I mean, we saw all those different groups of folks from NASA and SpaceX, from all different walks of life that have come together to make this happen. And that was just a small fraction of them. Look at that shot. That is so cool.
Wow. A little thumbs up from, I guess that's from Bob.
Yeah, and it took a little bit of creativity to get this shot to happen. We have a chase vehicle that's on the other side of the road, which is of course shut down, so we could get a camera in there and follow them out. So we are really thankful to Kennedy Space Center Protective Forces for helping us make that happen, so we could see Bob and Doug all the way out to the launch pad.
My ride out was a little bit different than what they're experiencing in this Tesla, because we had the Astrovan had bench seats on each side, and we could look across at each other as we were driving out. And it was moments where we would tell some jokes and look, but sometimes we would just look at each other, and we had such gratitude for having this opportunity to launch into space and to think about all the people that had a hand in helping us get in that vehicle to drive out to the launch pad to get ready for this momentous moment. And I think that's probably, even though they're sitting side by side, I think they're probably thinking of the gratitude and the people that have helped them get here, so that they can be on the the pointy end of the rocket, getting a chance to go up to space. It's just a momentous moment.
And they're listening to some tunes too, I heard, right, Lauren?
Yeah. There are at least 3 songs on their playlist that are super interesting. The first is AC/DC's Back in Black. You know that one.
Yeah, well, who doesn't?
Right. Another one that they're listening to is the elevator music from the Blues Brothers film, The Girl from Ipanema. Oh, Leland.
Okay.
Got another career.
That's enough.
Career number 3.
That's enough.
Right. NFL, astronaut, musician. Yep.
And of course, they are also listening to the Star Spangled Banner, the Army French Horns version.
Now, we didn't have tunes in the Astrovan.
No?
And I know that the Tesla has a really kicking stereo system. Is that still the custom stereo system that's in the Tesla?
I haven't been in this one, so I don't know what they're rocking, but I'm sure it's pretty cool.
And again, for some perspective, they left the operations and checkout building just a minute ago, and so it's about a 9-mile drive from there to the launch pad. It takes them around 20 minutes, kind of depends on how quickly they're trucking.
The other thing sometimes that you hear as you're in the convoy is the helicopter, the Huey helicopter flying overhead, and it's kind of also you're thinking military, you're thinking really important things, and it's a moment that also kind of solidifies in you that, hey, something big is about to happen, and that boom, 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 the sound of that Huey is just in your head, and it feels good that all these people are helping you get there safely.
Yeah, I think we heard that actually coming by this
Yeah.
building earlier, because we were talking. I was like, I hope that's what I think it is.
And it was pretty low because it was pretty loud.
You could feel it, too.
I could feel it.
I took this drive yesterday in my rental car, and granted it wasn't in a Model X, and I'm not an astronaut, but driving to 39A, that same route, and trying to imagine myself in that headspace, it was pretty awesome. I got to figure out how to get on Falcon 9.
Lauren, we're all astronauts. We're in space.
That is true.
You just got to get on the rocket.
Yeah, well, Leland, there's a big group of people that want you there.
I think we should, listen to them.
Yeah, I'm all for it.
I think we should.
Maybe we should make that a poll question.
Yeah. Well, we should all maybe go to space. What do you think?
I am on board. I mean, not literally right now, but I would like to be on board.
Lauren, would you go with us?
Absolutely.
Okay, poll question.
And we have so many people watching online, sending well wishes to Bob and Doug. I mean, it started early this week as we were ramping up for Wednesday, and I feel like it's just been this buildup of momentum because, we were following along Wednesday, and now we're all following along Saturday, and we have people watching from home that hopefully don't have to work today and can really tune into what's going on here.
And we, as astronauts, truly appreciate all the support, all the social media feeds, and we think about, our families. We saw Megan and Karen there with their sons, wishing Doug and Bob well wishes and Godspeed as they head off in these Teslas to launch pad 39A that launched the Apollo astronauts. And I think, this is just one of those moments where everyone in this country is coming together to wish them well, to get them to space safely. It's a really great day.
And they are just now on Saturn Causeway. They just made that right turn onto Saturn Causeway. So to the right of the screen, that building is the Operations and Support Building 2. And on the left, it's out of view right now, is the Vehicle Assembly Building, that iconic building that processed the Space Shuttle and Saturn V rocket also.
That's where that mobile transporter used to take out the Apollo Saturn V rockets and the Space Shuttle. It's just an incredible machine.
And where they're passing right now, I mean, if we were to run outside, we could wave because we are off to the right of your screen there at the press site where you see a group of media there. So from this point they've still got about 3 miles to go from here.
I'll see you guys later. I'll be back in a minute.
You're gonna go hop in. And obviously it's not just Bob and Doug's Tesla. There's a number of cars in that convoy. They're being escorted by Kennedy Space Center Protective Forces and also SpaceX security. They have a flight surgeon there with them. And we've seen just a sprinkle of folks along the way. Normally we'd have a whole lot more people out here watching this, but we really appreciate you watching online and from home. Again, wherever you are, at the beach, watching on your phone, your tablet, your whatever mobile device you have, we're gonna be here every step of the journey, taking you through it moment by moment. There's a cool shot with the worm on the roof.
There we go.
The second place worm, yes.
The second place worm.
So, Leland, when I drive down this road on the way to 39A, on the left, there's that area where the crawler used to drive. Do you tell us a little bit about the crawler?
Yeah, right there you can see the kind of the gravel where the crawler actually crushes that gravel almost into sand. It's so heavy. When the shuttle will go out and the Apollo Saturn V rocket will go out, and it's just, this thing moves at a glacial rate to get out there because it's got this huge rocket or shuttle on it. But I had a chance to see that when my shuttle went out one day with Alan Poindexter, and it's just this enormous, tracks and vehicle, but you guys do it in a different way, don't you? You don't go out of the vehicle assembly building. You have your own building.
Yeah, we have a hangar right there on the pad, so we just roll the rocket up the hill.
You kind of do it like a Soyuz, where you just raise it up right there from horizontal to vertical, and it's done.
Yeah. Horizontal integration, so you don't need an enormous building in order to process the rocket and mate drag into it. And then once you pin into the pad at the very top of the hill, you raise it up vertical with the transporter erector.
And again, all these efficiencies to help us get people to space faster and safer. And this is going to be the future of space travel. And also the relationship between NASA and SpaceX working together as a team to get people up.
And at this point, the convoy is approaching pad 39A, and they're entering what is known as the BDA, or blast danger area. Now, before any pad technicians, engineers, or astronauts enter that area around the launch pad, the SpaceX and NASA teams do an internal go, no-go poll to make sure everything is clear.
This storied launch pad, which has been the beginning point for so many firsts, is the perfect backdrop for today's historic launch that marks a new first and a new era in human spaceflight.
And here's a view from our gantry near the Launch Complex 39A. So we've got another view of the convoy going by here. If I had to count up all the cameras we have all over the place for this, I'd be here all day.
That's a beautiful shot right there, looking at the Kennedy Space Center and Merritt Island and all of the nature around us. It's a big buffer from 39A so that we can be safe and launch our rockets off to space safely.
Absolutely, and a lot of people don't realize this is a national wildlife refuge. I mean, I pass turtles on the way to my car every day.
Well, when we would run from the operations and checkout building, we'd have to watch out for snakes and for alligators, and so to be really careful about the wildlife.
We used to have one who lived at 39A.
Oh, really?
Yeah, an alligator.
Oh, well, maybe we'll see him. We'll keep an eye out. Tweet at us if you see any.
Did you name him Worm?
Ooh, I was ahead of my time.
I don't know how an alligator would feel about being called Worm, Leland.
Yeah, well.
And we've got a ton of you following along on social media. Lynn says, as a fellow Missourian, we're so proud of Bob. Launch America, we will be watching from the Space Coast, cheering loud. And another comment, Godspeed and good luck, Astro Behnken and Astro Doug, hashtag Launch America. There you see the SpaceX horizontal integration facility. It's on the left of the screen now. We saw the front of it from the other angle. Or I'm sorry, no, there it is. I was getting my buildings mixed up, so it's on the right now.
Yeah,
Bigger building.
The other is the Falcon support building. It's where all of our offices are, and yes, you're correct.
Thank you for the correction, Laura.
There's our hangar. We process Falcon Heavy in there. There are other boosters in that hangar as well. And the rocket and Dragon that is on the pad right now was put together, or rather finally integrated inside of that hangar and then rolled out to that pad to go up vertical.
And there it is. That shot really gives you a sense of the scale of the Falcon 9 rocket. Those Teslas look teeny, teeny, tiny, making their way up there. And so as they make their way up to the pad, we're going to throw it over now to Hawthorne, where Jesse and Dan are watching the action. Hi, guys.
Thanks, Marie. Yeah, really cool watching the Teslas pull up, driving on the launch pad just a few feet away from the vehicle. This is awesome and getting really excited over here.
Now, we want to take you to a couple of special guests we have joining us. They are with Daryl Nail at the OSB-2 viewing location, NASA Administrator Jim Bridenstine, and also Kennedy Space Center Director Bob Cabana is there with Daryl. Hi, Daryl.
Hi, Marie. That's right. We're in the fifth floor of the Operations and Support Building here at the Kennedy Space Center with a nice view of Launch Complex 39. And the two men that you mentioned are here to join me to answer a few questions. We're excited to have them both here. And they are, of course, Bob Cabana, the director of the Kennedy Space Center, and Jim Bridenstine, administrator for NASA. Gentlemen, thanks again for making the time to be here. Of course, the big story right now, Jim, is the weather. So let's talk a little bit about that. We can see there's some clouds building. That was forecast. You took part in a weather briefing this morning. What do you know about the weather and the decision that was made to say, hey, let's give this another shot today?
Yeah, so what got us last time was the electricity in the atmosphere, and of course today there are in fact buildups. It doesn't look like there are thunderstorms at this time, but they are expected. The question is, when do those thunderstorms go away, and when those thunderstorms materialize, where are they located? We are predicting about a 50-50 shot of going this time, but given the fact that we are in late May in Florida, we have to take every shot we can get. So it's not likely that in a couple of days it's going to be any better than it is today. So we are a go for launch right now, and we are hoping that the weather will hold up. We almost made it on Wednesday, and the trend is better today than it was on Wednesday. So we'll see.
And I saw a forecast that said the clearing is supposed to happen right around 3 o'clock in the afternoon. So
that's right.
We're hoping that
launch is at 3:22,
right.
Clearing, at the earliest 3 o'clock, at the latest 3:30. So depending on when that happens, we'll either be go or no go. But again, we're going to take every shot we've got.
Also watching the downrange weather for a potential rescue in case there were an abort.
That's right. So we have these staging areas. When we go from the first stage to the second stage, that's a higher risk evolution. We want to make sure that in the case we have to exercise the launch abort at that point, that the weather is good. And of course, that's off the coast of North Carolina. The big thing there is, it's great that we have a launch abort capability. The challenge is that launch abort capability includes parachutes. And with parachutes, you've got to make sure that you've got the weather to come down if there are thunderstorms or downbursts or high winds. that's problematic for the parachute system.
Right, and sea states as well, bouncing that capsule around in the ocean. Bob, of course, you're an astronaut. You know what it's like to hit the reset button and do it all over again. Get into the spacecraft, get ready to go, only to be told, no, we're not going to go today. We're going to try it again. What's that like? And then tell me about the mindset as you have to kind of reset. Do you feel less anxious? Do you feel more comfortable the second time around?
You know, Daryl, first off, my last flight, we counted down to 18 seconds and didn't go. Man, and when you get to 18 seconds, you're ready. Yeah. The key is, you know, it's the training that we go through, all the repetition that we do. We practice everything, including scrubs. And just because you didn't launch doesn't mean you don't have something to do. So you got to go through those back out procedures. It's all done very professionally. Then it was out of the vehicle and into the Astrovan, back to crew quarters. And we had a positive attitude. We got a good night's rest. And we went through it again. It's a matter of doing your job. And these guys are well prepared. You know, it's all part of what we do.
Yeah, they stopped the count at 17 minutes, but you had it all the way up to just a few seconds. That's a big difference.
And the truth is, the next night, actually everything went really better. You know, the weather was bad the first time. I was kind of glad we scrubbed. And we scrubbed for an issue with the vehicle that they later sorted out. As it turned out, we wouldn't have had enough prop to rendezvous with the Russian functional cargo block. But you know, the next night, it was just a perfectly smooth launch count. Everything just went like clockwork, and it set the stage for an awesome mission.
I think you told the press before you walked out, I think you were over there at astronaut crew quarters, we're going today. I'm wondering, where's the source of that confidence coming from?
I just got a feeling, you know, you got to have a positive attitude. I watched a lot of weather down here supporting shuttle missions, and I'm hoping that those clouds over the I-95 corridor, that the Indian River keeps them west of us, and that stuff that's building offshore is far enough off that we can stay in an open window here at the Cape.
Good. Well, we got your positive vibe going, and we appreciate that. Jim, when you were down in the astronaut crew quarters and when they were suiting up, you got a second chance to visit with the astronauts. Kind of tell us about that, and what was their demeanor, what was their mood today?
So again, they seem loose. They were loose last time, they're loose this time. They're definitely ready to go. They're excited. They've been wanting to go for a long time now. I'll tell you one thing that I thought was a little interesting is, Bob Behnken was making fun of Doug Hurley because on Doug's last flight, they scrubbed 5 times before launching on the 6th time. So Bob Behnken seems to think that Doug Hurley is the problem in this case. But to see them joking about that as they're getting suited up, ready to go. Yes, they're trained, they're ready, but they're also loose, and that's good to see because they're going to have to be on their game when we launch.
These guys are pretty impressive. Doug Hurley and Bob Behnken. I mean, Doug Hurley, an incredible pilot. Bob Behnken, he's got a PhD in mechanical engineering.
And he's a flight test engineer himself in the Air Force. Yeah.
Well, in your assessment, why are these guys the right stuff?
Well, this is a test flight, and we have great astronauts that are chemists. We have great astronauts that are botanists. We have really talented and diverse, a very very diverse astronaut corps in general. But this is a test flight, and for a test flight, what do you want? You want test pilots. You want people that, for a living, they have made a living flying new things that have never been flown before. And Bob Behnken and Doug Hurley are the two people that you would want in a test flight, and that's exactly what this is.
Bob, you're a pilot too. You want to weigh in on Doug Hurley? He seems like he's got the right mentality and a smooth customer.
He's a naval aviator, a marine pilot, a test pilot. I'm all in. He's a great guy.
Yeah. And tell me a little bit about in terms of the Kennedy Space Center, right? So you've been here since 2007, right?
2008.
2008. Sorry, off by 1 year. 2011, the Atlantis came to a wheel stop. I grew up here. My dad worked for NASA. My uncle was a contractor. When that wheel stop happened, the next day, my uncle got the layoff notice, right? And it 30, 60 days. It was depressing. We're talking about thousands of people laid off.
Super depressing. Atlantis landed on a Thursday. On Friday, 2,000 contractors got pink slips and walked out the door. Yet they worked on that vehicle. That was the best vehicle we ever flew, the cleanest. That's the dedication of the workforce here.
Right. So, and take me back to that time. You called it a depressing time. The fact that the shuttle program was something that the government completely had ownership of and paid for. Now we're moving into this commercial crew, which you've overseen making that transition. And tell me about that 9 years in which we made that move?
Well, obviously, everybody was really attached to the shuttle. I mean, it was our history for 30 years and did an awesome job. The Hubble Space Telescope, all the satellites it deployed, building the International Space Station. But when I first got here, I told everybody the shuttle program's going to end. We have to start preparing for our future. And nobody wanted to hear that. But how many times in your life do you get to define what you want your future to be? And we set out on this bold goal of trying to turn KSC into a multi-user spaceport, supporting both government and commercial operations. And I've got a very persistent team. They worked extremely hard, and through a number of agreements, we were able to make it happen. And this is the future. Commercial spaceflight, the administrator says it all the time. We want to establish a commercial environment in low Earth orbit so that we can focus on the hard job of exploring beyond our home planet, to establish that presence in our solar system beyond planet Earth, establish a sustained presence on the moon, get to Mars, establish a presence there. We can't do that if we're locked here in low Earth orbit. And Commercial Crew with both SpaceX and Boeing, that's the beginning of a whole new era of spaceflight.
All right, very good. Quick question. We've got, of course, a special guest coming back today. The President of the United States plans on being here. Jim, you took him around the first time around. How did that go? I think I saw a picture on Twitter. He signed some space hardware.
That's right. So he took a look at the Orion crew capsule. Of course, the Orion for Artemis 1 is ready to go. And he signed a piece of hardware that will fly on the crew capsule for Artemis 2. So that's kind of, and not just him, but the First Lady and the Vice President and the Second Lady, they all signed it. So their names are going to fly around the moon on Artemis 2, which is exciting. But I just want to give Colonel Cabana a compliment here, because he did bring this spaceport through a very difficult time. And now it is a multi-use spaceport, and we do have commercial, and we have, in fact, even international launches here, and now we're going to have commercial crew launches. Bob has done a wonderful job transforming this spaceport. That's why we're doing commercial crew. NASA wants to be one customer of many customers. We want to have numerous providers that are competing on cost, innovation, safety, driving down costs, increasing access. But even better today, when I took this job just a few short years ago, our budget at NASA was around $19 billion. The budget request that President Trump gave us for next year is $25 billion. We are in a great position because the President is committed to space exploration. Of course, he's committed to the Space Force. We haven't had this much support for space since John F. Kennedy, and we've got bipartisan support. Everybody wants to see the Artemis program be successful. Everybody wants to see not just the next man, but the first woman on the moon, and that's what we're building here.
Yeah, it's key to it all is that bipartisan support, and of course, what the work that Bob's been doing here. You can see the commercial activity all around this place. We're going to get to some questions on social media real quick that our audience wants to find out. So the first question is from James on Twitter, and he asks, what is the hardest part of going to space? And we're going to have to give that question to Bob.
Well, Daryl, nothing's hard if you prepare for it. And what we are afraid of is stuff we don't have knowledge about. And that's what we do when we learn how to be astronauts. We train, okay? You spend a long time as an astronaut candidate learning. You spend a long time preparing for a mission. For an International Space Station mission, training around the world on all the different modules and everything, it's like 2.5 years of training before you get on orbit for that time to actually do your work. So I'd have to say the hardest part is the preparation for it. But you are so prepared when you go. You just have total confidence. You know that you are very well trained for what you're going to do. You have an outstanding team on the ground supporting you. And that is so important to have that ground support as you climb into that vehicle. You know that they've done their very best to ensure your safety and a successful mission. But after that, it's a piece of cake, except no simulator on Earth can prepare you for what those guys are going to feel. It's better than a cat shot off an aircraft carrier.
I believe it. Maybe one day I'll get to try. The commercialization effort means we want everybody to be able to fly into space. That's
Absolutely.
the goal.
It's a great point about preparation, because that's not the highly visible part. The launch is, and so it's good to know that all that preparation leads to that confidence. By the way, just an update operationally, they're getting ready to close the hatch door. You can see on your screen there, the workers there are getting ready to get that closed. and working on that right there with Doug Hurley and Bob Behnken on the inside of Crew Dragon. Our next question is from Mathis on Twitter, and he asks, what kind of operations will the astronauts do between the liftoff and docking with the International Space Station? I know you pay a lot of attention, Jim, to the operations, especially of this mission.
You bet.
What do you know about that?
So there's a number of things. The first thing that they have to do is, of course, we've got a number of burns to get in phase with the International Space Station. We've got some boost burns as well. We're talking about, operating the rocket engine to get in alignment with the space station. But I'll tell you, the biggest thing that we need the astronauts to do once they get on orbit and before they dock is rest. We need them to be prepared for that docking range of the International Space Station. They're going to start maneuvering the spacecraft themselves. Not automatic, but they're going to do it themselves. They are, in fact, test pilots, and as test pilots, they will test fly this vehicle to make sure that it operates as advertised. And of course, then they will dock with the International Space Station. And a unique capability here is it's automatic rendezvous and automatic docking. And so we're going to be able to see that for the first time as well.
That's going to be exciting to see. Thank you for sharing that with us. Jim Bridenstine, Administrator of NASA, Bob Cabana, Director of the Kennedy Space Center, thank you both for joining us. And we're going to send it back to Marie in the studio.
All right, thanks a lot, Daryl and Mr. Bridenstine and Mr. Cabana for joining us. You can see some clouds starting to gather over Launch Complex 39A. We're keeping a close eye on weather. Again, 50% chance of launching today. We just got to see what the weather's going to do. A little bit ago, we heard the crew complete their comm checks live on the air. We saw their seats rotate. That helps get them into a little bit more comfortable position for the G-forces during launch. And more importantly, it helps them be in a better position to interact with the screens in front of them. They completed their suit leak checks. We saw during the interview just a few minutes ago the hatch begin to close, and so inside the white room there, the pad closeout team is in there still doing some work. That hatch close is, it's not as simple as just closing a car door. There's a process to seal it and check it and make sure that everything is sealed properly, right, Lauren?
Yeah, that's correct. If they haven't already started, one thing that will be coming up next is the leak check. What they'll do is they'll attach a piece of ground support equipment. They don't have it in their hands right now, so it looks like it hasn't started yet. There it is. You can see it there. The closeout member number 5, it's already attached to the side hatch mechanism. And what they'll do is they're essentially checking for the leak rate. And they'll hold pressure there for a few minutes and then track that change in pressure over time to make sure that it's within bounds, making sure that you don't have any issues with those O-rings there that are holding that pressure. And so once they complete that leak check, they will then do what is the called the installation of, or the final installation of the SPEP, or side pressure equalization plug. That's basically a plug that once the capsule splashes down, what you'll do is actually remove that, and what it does is equalizes pressure across the hatch. So once that thing is plugged in, you know that everything is super tight and that you shouldn't have any leaks on orbit.
One of the other things that I think is pretty cool about Dragon, you can kind of see them on the edges there are some of the windows. And I know that Dragon started out as cargo. It was Cargo Dragon. You have your cargo version, and before you moved on to the Crew Dragon version, but you even had windows on the cargo version. Can you explain kind of why that was?
Yeah, the very first Cargo Dragon that we ever launched had a window over the hatch, over the side hatch, and the reason we did that is we've always envisioned Dragon to ultimately be a crewed vehicle. So even in the beginning, for the very first vehicle we ever made, which didn't even really carry much cargo, we put that window there, and it to us symbolizes what Dragon's purpose has been all along. Taking those steps, starting off with the CRS program and resupplying the space station with experiments and food and crew provisions for the astronauts on board, to now putting putting NASA's astronauts in our own vehicle. It's that natural progression to what we were aiming for the whole time.
Mm-hmm. And Leland, what's your take on the touchscreen technology? We saw a little bit about that. Obviously, this is a very different kind of look than what we saw during the space shuttle.
You know, it's the future. I mean, we had our LCD displays and we had lots of buttons to press and, you know, valves and switches. And I think this new technology will allow us to get through procedures much more much faster, because we had, you know, paper flight data file that we're having to turn to different pages and get to things. And I think this will make it much more efficient to go through your malfunctions and your procedures with the touch screens. And I think, you know, having the gloves, being able to, you know, touch the screens and work within the gloves, everything's kind of sleek and efficient. You know, there's not a lot of wires and things hanging off, and their knee boards, you can see their knee boards on their left knees. And so that's for some extra little notes and things.
The hatch is closed now.
There's some commentary.
We are ready for the post-ingress briefing when you are ready to copy.
And we just heard confirmation on the loops that the hatch is closed. So that is a little bit ahead of schedule.
We are motivated to go today.
We're ready. Go ahead. Okay, on the weather, we still have some rain showers moving through the area, but we do have a reasonable opportunity today, so we are proceeding into the count. We are going to take a look at both pad and ascent track weather at T-minus 1 hour and 30 minutes, and the next decision point will be prior to prop load.
Okay, we copy.
And on the vehicle health front, both F9 and Dragon health remains nominal with no items of note.
So we just heard the weather is still iffy.
Good news. Thank you.
The weather is still iffy.
This concludes the post-ingress brief. Report when ready for comm checks with Falcon 9 operators.
We are ready for the F9 operators.
Copy. Expect that shortly.
So when we hear that chatter pick back up, we're going to quiet right down so that you can listen into that along with us. But we just heard them discussing the weather briefly, still keeping an eye on that. But the next decision point is going to be before prop load. So we're going to press forward for now and then reevaluate before they start fueling the rocket. But in the meantime, it sounds like Falcon 9 and Crew Dragon are healthy. So the vehicle's in good shape, right? It sounds like kind of a little bit of a repeat from Wednesday, that we're just keeping an eye on the weather at this point.
You can see on their left legs, well, in that previous image.
Dragon SpaceX comm checks with F9, you can expect it in about 1 to 2 minutes.
Dragon's ready.
All right, on their left legs there, they have these satchels that are strapped to their legs. Inside are some crew provisions, including these tablets that you see that they have displayed there.
You say, Lauren, those are tablets versus just kneeboards that you can write on?
Or the tablets are inside.
Oh, they're inside.
Yes.
Okay. Okay. And so when would they pull those tablets out to use them?
During the mission,
Okay.
while on orbit.
Okay.
And I don't know if it's coming, if the background noise is coming through over the air, but we hear the rain really picking up outside the studio here. So I'm kind of wondering if Bob and Doug are hearing the sounds of the rain clouds opening up over the pad. Looks like it's still kind of patchy out there. But again, we were following some thunderstorms that look like they may be making their way over here. It kind of looks like it's raining from that view. It's a little bit hard to tell through the haze.
All right, launch is now just over 2 hours away. Tahira, you are there with the social teams. Now that the hatch is closed and the rain's picking up and all kinds of exciting things are going on right now as we count down and get into the last 2 hours of the count, I bet things are getting pretty interesting on social media.
Hey, Lauren. I mean, yes, they are. So many different things are going on right now, and I think people online are just wondering what's going to happen with today's mission. I have TweetDeck open right now, and it is just scrolling with the conversation of people around the nation talking about today's launch attempt. We also just checked viewership, and we are now up to 1.4 million people watching this live broadcast, so really hope things look good with weather. And on that note, let's take a look at some of the things being said on Twitter right now. So it looks like, oh, we just have some more future astronauts. I really love seeing the young generation just getting mobilized, getting excited about today's mission. Looks like we've also got some Godspeed and safe travels for both astronauts today. Really do wish them the best of luck on the second attempt. Hope it happens. Some throwback photos, all from people visiting NASA's centers, and also just let's do this. I love this can-do attitude, and I just love seeing that people are still keeping the energy alive for today's launch. So there were obviously some disappointing reactions to Wednesday's scrub, but let's take a look at how people are getting excited for today's attempt. Let's roll.
Ready for takeoff.
Ready to launch America.
3, 2, 1, go!
Ready for liftoff?
To infinity and beyond!
I mean, how fun is that video? I think I will definitely have to attempt the worm after this, but just really glad to see everyone in good spirits leading into today's second launch attempt, and I really hope everybody will have something to smile about. And with that, let's head back to Lauren. Lauren.
Thanks, Tahira. So it looks like people are pretty stoked about today's attempt. Please continue to join the conversation by using the hashtag LaunchAmerica across all the social media channels.
Yeah, I really love seeing the little kids get excited. I know my 3-year-old is super excited. She's got an astronaut sleeping bag and
Really?
she loves to climb in it. Yeah, it's the body of the bag is a spacesuit, and then the head is empty where the pillow is. So when she gets inside, it looks like she's got a spacesuit on. So she loves it.
That's the inspiration for that next generation of explorers going to take Doug and Bob's place one day. And I think we have some people out there that are so interested in our conversation about the worm and the meatball that they've created something called the worm ball.
What?
Yeah, I was checking my email during that because I emailed you guys the worm ball, and I was like, what is this? I'm having a hard time seeing it, but what is the worm ball?
So it's a NASA meatball, which is, what it should be.
Yes.
Okay, look at it. There it is.
All right, thank you. I need a visual.
So they took the angular NASA logo and put in the worm inside of the meatball. Can you live with that, Lauren?
You know what? That's a beautiful compromise. I'll take it. I'll take it.
It's a nice marriage of the two.
Oh, I love you, man.
Yeah, truth.
Stage 2 lock float is closed out. Propellant fills are complete. Dragon is in auto idle.
Stage 2 LOX load complete. All fuel, all oxidizer on Falcon 9. 1 minute 34 seconds to go till launch.
Ground gas closeouts is starting.
Falcon 9 is in startup. Dragon is in countdown. FTS is armed for launch.
Under a minute now, the FTS, the flight termination system, has been armed.
Dragon, SpaceX, go for launch.
SpaceX Dragon, we're go for launch. Let's light this candle.
T-minus 30 seconds.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX. Godspeed, Bob and Doug.
America has launched. And so rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
T plus 30 seconds into this historic mission. Flying crew on board Dragon and Falcon 9, and look at them go.
Falcon power telemetry nominal. M1D throttle down.
We're throttling down to get ready for the period of maximum dynamic pressure. We're in the throttle bucket. Reports say all systems are go.
Vehicle is supersonic.
We've exceeded Mach 1 on the Falcon 9.
M1D throttle up.
We're throttling back up to full power as we're through max Q.
Copy, 1 Bravo.
And we heard that 1 Bravo call out. That's just the second abort zone that they're in. They'll continue to be on this until the first stage has done its job and they switch over to the second. At this point, Bob and Doug pulling about 2.3 Gs, 2.3 times the Earth's gravity, already moving at over 1,500 miles per hour.
We've heard the call out for MVAC engine chill. That's getting the MVAC engine ready to light. That'll come at about 2:44 into flight. Right now, everything continuing to look good. Next major event coming up is going to be the triple. We'll have main engine cutoff of the 9 first stage engines.